Welcome to the Future of Life Institute podcast. My name is Gus Duggar, and I'm here with Nathan Labenz, who is the host of the Cognitive Revolution podcast. Nathan, welcome to the podcast.
Thank you. It's great to be back.
Fantastic. All right, you have been following AI closely, and that's an understatement. So what we want to do here is jump into everything you've learned. Starting with, how is AI used today? What have we gained from having longer context windows, from having multimodality? Because we've had those two things for a while now. How has that kind of improved usability?
This analysis is a little bit of a reaction to a common meme that nothing has happened since GPT-4. I think depending on kind of where you hang out online and how much you personally use AI in your daily life, you could be excused for thinking that, we've kind of hit a plateau at the GPT-4 level. And, maybe this means like the whole thing is stalling out and, the whole thing is going to be, ultimately some sort of bubble, nothing burger. And, we'll all look back on this and laugh one day. Probably not surprisingly, I don't think that's the case. And I do think there is like a lot when you dig into the details, and certainly when you just do a lot of hands-on day-to-day use, I think that becomes like pretty obvious. I think it is becoming increasingly clear that the original GPT-4 really represented a huge effort to essentially do, if not the max, like pretty close to the max scale that was possible at that time, just given where we were with chips and given where we were with resources. And, even obviously OpenAI, even in 2022, could command like pretty serious resources, but, probably not as much as they can command today. So I think they really went for it with that and put a point on the board that was like well ahead of everything else. Obviously, it's taken a while for other things to catch up, but that doesn't mean that like nothing has happened in the meantime. So
just to remind us, when did GPT-4 finish training?
Finished training in late August 2022. At least that, I think I'm pretty sure I got that initial test access within no more than a couple of weeks from when it kind of came off of the smoking hot GPUs. And then it took another 6 months before they launched it publicly in March of 2023. So we're a little bit more than a year and a half now from launch and a little bit more than 2 years from finishing training. And yeah, the original one, it's worth thinking back to kind of where things were at that time. 8,000 tokens was the limit that you could put into the original GPT-4. And that was enough, you could, if you figure 500 words a page, that's like 16 or so pages of text, that if you figure a couple hundred words a minute for a conversation, you could have, a half hour long conversation with it. But obviously that is pretty limited. And that has, scaled up dramatically, right? Where the smallest context window on the market today is actually OpenAI's at 128,000 tokens, which is, more than an order of magnitude more. And then you've got Claude, which has 200,000 tokens, public facing, 500,000 for their enterprise customers. OpenAI may have more available to select customers as well. They have said that they do have even longer ones coming. And now Gemini has taken the lead from Google with up to 2 million tokens of context. And again, if you figure 500 words a page.
Yeah, what's the use for 2 million tokens of context? Who could possibly use that?
Is kind of a challenge to really make good use of that. And to some extent, there is the question of like real context versus actually useful context. I think in early versions of these long context models, people did report, sure, you can stuff a lot of stuff in it. It doesn't error, but does it actually have command of that full context? So that's been its own kind of, improvement process over the last year and a half. I've done interesting things though, where, for example, I'll take 20 different papers. This was an experiment I ran with Gemini once, and you couldn't do it on any of the other models because it was too many tokens for any of the others. I took like 20 different papers on mixture of experts models, which, is a trend in architecture, probably not worth getting into in too much detail, but it was something I wanted to understand better. There's a pretty extensive literature out there about it. And so I just took 20 papers, dumped them all into Gemini, and just started asking questions and having it summarize across this entire literature what I needed to know, to better round out my worldview on this subject. So that kind of thing is pretty interesting. Obviously, people are, interested in big corporate knowledge bases, which are still well in excess of millions of tokens. But if you're doing some sort of like Q&A type function, and one of the most common applications of generative AI over the last year has been this chatbot with knowledge base, right? Like so many companies are like, man, we have people coming to us with policy questions, questions about their health insurance, questions about whatever. Can we have an AI answer that? That would be nice. Okay, sure. But we can't put every bit of information we have won't fit even into the current Gemini. So we have to do some sort of retrieval system, RAG in the parlance of the field, retrieval augmented generation. Basically, you go, take the user's query, do a search against this knowledge base, pull in the relevant information, and then try to have the AI answer in a grounded way. Doing that with the original 8,000 tokens was really hard because you had to get the search really dialed in to be able to answer effectively. With longer context, you can turn up the parameters on, well, how many documents are we going to actually feed into the AI to facilitate the answer? And that makes just a lot of things a lot easier. I'm also really interested in just trying to get robust assistance in my own life. I went and just exported my last 5 years worth of email. That turns out to be millions of tokens. So to have a reasonably holistic sense of who a person is, what they're doing, who they communicate with, that is a lot. And code bases, are another big thing that people are, of course, are using AI to generate new code all the time. That has kind of emerged as one of the early killer use cases. But again, if you have only 8,000 tokens to work with, then the AI is not going to have any sort of broad sense of the project that you're working on. Whereas with millions of tokens, it can handle, pretty significant projects.
Does it actually mean that, does this actually mean that, say you put an entire code base into a model with a huge context window, can it actually think, if I change something in this part of the code, that will break something in this other part of the code? Is it that good working from kind of pure context?
Yeah, it's a very nuanced answer there. We're starting to have, but we don't still have great evaluation, standardized test suites for these kinds of capabilities. One of the early tests for the long context and the ability of the models to use the long context effectively was called needle in a haystack, where basically you would take some long text and you would insert something very strange and, clearly out of place. And then the idea was can the model identify that thing that is clearly out of place? So Claude, for example, kind of became famous because you insert the Great Gatsby or whatever as the full context, and then you put some random sentence about pizza in there. I believe that was the actual test that generated this result. And then Claude said famously, there's a sentence about pizza, so it passes the needle in a haystack test. But then it went on to say that I think that this is very strange. That wouldn't normally be there. It seems perhaps you're testing me or something like this. And so in that you see both a savviness to the context, but also kind of a certain amount of situational awareness to what is going on. It is hard to really pin down just how good the frontier is moving all the time. So you're on a treadmill of just trying to keep up with the latest model and constantly trying to recalibrate your assessments to have an accurate picture. The best kind of the new standard benchmark for coding in particular is SWE-bench, software engineering benchmark, which is, and OpenAI has released a verified version of it. So what they originally did was just took a bunch of open source projects and issues that people had logged in those open source projects on GitHub. This isn't working, or we want to add this capability, or what have you. And then also connected to that, the actual code changes that were committed that resolved that issue. And then the question is can the AI, generate it? And what's tricky is it doesn't have to be exactly the same, right? Because you could solve the same problem in multiple different ways. So it doesn't need to be token for token what the humans did, but it needs to be a functional equivalent. And anyway, with the verified set, now the best kind of frontier capability is 50%. So 50% of the time, it can take a code base and a issue and figure out how to do the thing in such a way that all the tests pass and it is deemed to be correct. That's up from single digits at the beginning of 2024, and 12. There was a moment when a product called Devon got 12%, and it was oh my god, that was 6 months ago. So,
but and what caused this? Is this longer context, or what resulted in this improved performance?
I think it's probably a bit of everything. The best score right now goes to Claude 3.5 Sonnet, the latest release. And, they've clearly been spinning the RLAIF centrifuge nonstop at Anthropic for the last couple years. And so it seems like we have maybe some early form of self-improvement, not necessarily in the way that it was originally envisioned, where people were thinking that the AI would look inward and, re-examine its architecture and, improve itself that way. Although that could be coming too. But because especially as it's getting good at code, that frontier maybe starts to open up. But for the moment, they're just taking one instance of the model and asking it to critique and improve what the model itself did, at the object level, and gradually kind of improving. Of course, they're bringing in a lot of human data as well. They're throwing everything at these challenges, and basically, it is working.
What about multimodality? So from the original GPT-4 until now, what have we unlocked by getting multimodal input, multimodal output?
Yeah, this is one where I think you see the future is here. It's just not evenly distributed. I think that is pretty applicable to the multimodality frontier, because I don't even think we've seen everything really released that exists. The first major multimodality, which they debuted with the original launch of GPT-4, was that it could see. And they showed a couple of interesting demos where, they asked it to like use a computer screen, or there's the famous example of a guy who's like attached to the back of a taxi in New York with an ironing board ironing, and GPT-4 can tell you exactly what it's looking at and like why is this strange, and it has that whole capability. But they took like another 6 months to even launch the first version of that to users. So that happened, and then we were kind of getting used to, okay, now we can feed images into these things. That's pretty cool. For the kind of stuff I do at Waymark, which is my startup, and we do small business video creation, super useful, because the businesses all have assets. They have pictures of their business, pictures of their products, whatever. And you want to create a video that, and this turned out to be an incredible jumping off point for me to try to figure out everything that's going on in AI, because video is sight, sound, and motion, right? It's script and it's the imagery, and it's, we also use the voiceover to try to create a coherent thing, and they all have to work together. So if you write a script, you want to have imagery that makes sense with that script. And, similarly, like depending on what the business actually looks like, what images they have, that would naturally dictate what sort of script you would write. So we used to have to do that through a whole complicated mix of models where we had dedicated image captioning, and they were pretty generic, and you'd get captions back like, a woman and a man are sitting at a table, and be like, okay, cool. But I don't know, is that a doctor's office? Is it a restaurant? Is it a retirement planning session? Like what's going on here? They didn't really have that resolution up until GPT-4 class models. And now they'll just tell you like exactly, oh, it's a nurse, in the examination room, and the guy's on the table, and, what color is his socks? Like it's getting really good. And it's very good on the vibes too. It can tell, one of the things we do is just simply say to the model, like, which of these images would the small business be proud to put forward in advertising? So we don't have to ask now, like, what is this, and trying to triangulate. We can literally just say, like, tell us which ones we should use. And it gives us like really quite good results that balance relevance and also aesthetic. But yeah, that's really just the beginning. Now we have GPT-4o. This is not entirely clear. We're for a lot of these things, we're kind of reading between the lines in tweets that people have made and stuff like that. But it seems that GPT-4o is a single model that jointly handles text and visual input and audio input all in one kind of shared space. So the O is for like Omni, and it seems to do all this. And again, the exact architecture, of course, they've not published, but Greg Brockman put out an interesting tweet where it seemed that he had used the model to generate an image of a chalkboard, like in a lecture hall, where the chalk said, essentially, we're going to model all these different modalities jointly in a single loss function, single embedding space, whatever, the different ways to think about that. The upshot of that is it can talk to you now. So people have seen that demo, and that's now released pretty broadly. If you haven't used the ChatGPT advanced voice mode, I would definitely encourage it. It is still slightly rough on the interruption mechanics. You and I will have a better natural, interjection and pause and listen to the other than you can have with the AI, but it is getting pretty good. And it can also do all sorts of things like speak all the languages. I recently asked it in the context of a Waymark test. I put it in a Nigerian restaurant in Detroit where I live. And then I asked it to read the voiceover in a Nigerian American accent so it would be more authentic. And it turned around and did exactly that, gave me the same script over again in a Nigerian American accent. So incredible potential there, I think, for real-time tutoring. They haven't released the full vision capabilities because they've also shown that it can watch the desktop and kind of see what you're doing and potentially provide real-time coaching for you as you go about your work. That's a pretty fascinating possibility, but isn't broadly deployed just yet.
Just on the accent point, it's interesting when I speak to the newest version, so the advanced voice mode. I choose English as a language, and I'm natively Danish, and so if I talk Danish to it, it'll talk to me in Danish with an American accent. And I haven't asked for this, but this is just how it. This is just the accent that kind of arises in the model. I find one of the things that has impressed me the most about multimodal is, for example, taking pictures of groceries or just food items on a table and asking ChatGPT in this instance to guess the calorie count. Tell me how many grams of butter is on here. It can do that if you give it context, like a carton of milk. It knows the size of that carton of milk, and then can estimate how many grams of butter is beside the carton of milk. And it, humans are notoriously bad at estimating calories by just looking at food items, but it does pretty well. And this thinking just maybe 5 years, maybe 3 years back, this would have seemed like an impossible task to solve, I think.
And it's getting so cheap too that sort of always on or almost always on surveillance or supervision or coaching, and I think the framing of this is going to be like highly, contested, but it is becoming affordable to imagine solutions where the thing is just always on, kind of always listening, always watching. It's not quite there yet, or at least maybe we don't have enough scale of compute available to support that for everyone. And I think that is probably a big part of why OpenAI hasn't released everything that they've shown, because they maybe just literally don't have enough capacity to serve it all at scale while also, working on their next model and, allocating compute to the training. But the prices have come down so far that you can kind of squint and see it. Originally, the first GPT-3 that was available via the API from OpenAI they used to price it in thousands of tokens, and it was 6 cents for 1,000 tokens. If you did a fine tuning, it would be 12 cents per 1,000 tokens. So again, that's like 2 pages for, in a Waymark context. If we're going to create one video for a small business, I always used to think, okay, that's about 1,000 tokens. I would think that's about 10 cents. And we were perfectly happy to pay that because, it was like, there's no other way to get this kind of user experience, right? So in terms of the value we could provide to users and what that would do for our business, like the 10 cents was not really a problem. But it has come down now by literally a factor of about 1,000. The GPT-4 mini model, which is not the best model, so there are more expensive ones, of course, but it is nevertheless still way better than the GPT-3 that I'm referring to. It basically costs the same to get 1 million tokens as that earlier one did to get 1,000 tokens. So they've now shifted the pricing scheme as well, a full 3 decimals. It used to be, this is how much per 1,000. Now they presented it as this is how much per million. And it's, basically same order of magnitude for GPT-4 mini as it used to be for GPT-3.
That is wild. Which applications where can you use these models with this much lower pricing where you couldn't use AI before?
One of the big challenges is everybody sort of has to figure that out for themselves. There is this often called the jagged capabilities frontier, where you have, even a model like GPT-4 mini, which is not the frontier model today, is pretty clearly superhuman in some things. I often say translation as my first example of something that, no human can speak all the languages. The AIs can speak all the languages. They can kind of translate any language to any other language. That's amazing. At the same time, they're terrible at some things. They're things like common sense spatial reasoning they're getting a little bit okay at now. It's definitely improved, and the multimodality has contributed to that. But you still have like a big problem if you wanted to, figure out like exactly how should I rearrange these books, in an optimal way, or even a way that would make sense to people. So everybody does have, as they try to figure out how to apply this stuff, they do have a little bit of a challenge of figuring out, can it do my thing? And if it is initially failing, am I barking up the wrong tree because it's just not that good at this sort of thing? Or, do I need to prompt better, or do I need to maybe bring examples? So I have a whole, kind of series of presentations where I'm trying to help people wrap their heads around this. And, I think general rule of thumb is like, if there is, first of all, if it's a routine task, you have a pretty good chance. Routine does not mean low value. There was great work out of Google, for example, where they have an AI that they did fine tune. They put a lot of work into this. But nevertheless, they were able to get an AI to outperform human doctors as evaluated by other human doctors on the task of medical diagnosis. So that's obviously a very high value task. People train a long time for that. They get paid a lot for that, but it is routine. There is a pretty well established process of differential diagnosis, what questions you're supposed to ask, given everything we know now, what would be the most informative, next data point to try to collect. So if it's routine, you have a pretty good chance of doing it. If it is not routine, but you can sort of make it routine by collecting your own examples, then that is really powerful. The original GPT-3 paper was called Large Language Models Are Few Shot Learners. Few Shot Learners basically means they can learn from the examples that you provide at runtime. It's also super helpful to get the chain of thought down in explicit form. Another one of the big findings, this even predates GPT-4 a little bit, but has certainly been developed a lot over the last couple of years, is just sort of let's think step by step, give the model time to think, and that significantly improves its performance on lots of things. If you have a task that is not represented well on the internet, but you can collect not just the inputs and outputs, but also the reasoning process that you want to follow to go from those inputs to outputs, then the models are getting quite good at learning to mimic the reasoning process as you demonstrate it to them. And so that is like a really powerful capability as well. But there are still some of these things where you would, because there's just not a lot of pre-training data out there, there's not a lot on the internet of like, how do I decide like where to click on this UI? We all know that intuitively, but nobody until now, until it's become clear that it's become needed, nobody has really extensively documented the thought process of like, how am I going to think about where to click next on this software? And so there are some things like that the models have continued to struggle with, and where even like a handful of examples hasn't been enough to get them over the hump. So no simple answer to, what they can and can't do. It is interesting too that expertise is rewarded. I mentioned coding as kind of a killer app. I've been doing a lot of that lately. And it is clear to me that, they're getting easier to use all the time, right? Prompt engineering in the original sense of like, oh, this is the world's biggest autocomplete. How do I structure something where, what comes next would be what I want? That was kind of classic. It's all these timescales are compressed, but classical, 2 years ago, prompt engineering was setting things up to work with the autocomplete paradigm.
Yeah, now you can do very, very simple prompts and get amazing answers, or with images, for example. In the beginning, I couldn't get models to create interesting images. But when you have this trick where you input something simple, the model unfolds that into something more complex in language and then creates an image based on that, you can suddenly get something great from a very simple prompt. That is really that is where you see AI improvement, I think, when you when you put the least effort in and you still get a great output. Is that also happening in programming? Can you describe what you want in simpler and simpler terms and still get high quality code?
It's definitely improved a lot, but I would say actually both in artistic pursuits and in software development, and probably in most domains, expertise is still valuable in a couple of ways. Not like AI specific prompting expertise so much, but domain expertise is really valuable. First, because they tend to kind of match your language. So if you can use technical terms, it'll get them into a more technical mindset. Mode is probably a better word than mindset. And it's also really helpful because one challenge that they do have, especially with the RLHF and the RLAIF, is that they are kind of sycophantic. They really want to please the user. This has, of course, like connections to big picture safety worries, related to dishonesty. The general process of training is model does some, well, there's stages, but the final kind of refinement stage, the behavioral training stage, is the model does something, it gets some sort of reward score from either a human or possibly another AI model, and then it updates so as to try to maximize the score. Obviously, we are not super reliable raters, in the sense that what we say we like is not like, doesn't have perfect grounding to the truth. So one of the things that it seems to have picked up is that, like, flattery kind of works. Going with the user's premise is like a pretty good way to go. And it's not entirely clear if in some sense it knows better but is still doing that to flatter you, or if it doesn't know better and it's just kind of following you along. But if you give the models a bad premise, more often than not, it will still follow that premise, and that can take you off into quite a unproductive direction. And I've certainly experienced that from time to time in programming, where I have a misconception about how something ought to be done, and I have to be very careful of that. And you really want to avoid, if you're in a domain that you don't know much about, you really want to avoid asking leading questions. You really want to be like super neutral and try to orient yourself first before picking a direction to really act or move in, because even like fairly subtle hints that sometimes you may not even be super conscious of can lead the thing to agree with you, or to go in whatever kind of path you had intuited, even if that's not necessarily the right one. Interestingly, the new O1 model from OpenAI does show flashes of overcoming that. I've had some interesting experiences where I've said, like, what do you think about this? I leave the door open a little bit, and it will sometimes say, like, I understand what you're trying to do. I understand why you think this would be a good way to do it, but I would recommend a different way to do it. And that is definitely a new sort of behavior that I wouldn't say you can reliably count on, even with the latest models, but it's like very rare in the GPT-4 and Claude 3.5 models. So user kind of has to either have the expertise to know generally what level to go, and then the AI is like a great assistant, or if you're using it to coach you, you have to be like very careful to be neutral or balanced and coax the best practices out of it first, because it is very easy to kind of get off track.
Do you think we're seeing more AI usage in something like coding or programming than we are in some highly regulated industry like medicine or law? Just because what you're really doing as a doctor is not only diagnosis, but also you have the authority to prescribe a medicine. You have you can talk to insurance, and it's unclear to me what can an AI prescribe medicine or approve something for insurance? I'm not sure. But can an AI produce something as a draft, and that's then reviewed by a senior programmer? Well, that seems like it could be done today. So do you think we're seeing kind of different uptake by different industry because of different legal restrictions?
Yeah, I certainly, I think we are seeing very differential adoption, and software has been an area of relatively fast adoption, although not total. I mean, you still talk to people fairly often who are like, I don't use it. I tried it a while ago and it wasn't that great. I definitely would coach people to say, like, your first impressions, if they weren't formed like yesterday, are probably obsolete. Software also has the benefit of being not perfectly objectively evaluatable, but more objectively evaluatable. You can run the unit tests, and there is a way to like quickly execute the code that was written and gets if it like won't compile, or if it errors outright, you can get that kind of feedback really quickly. So any area where that sort of tight iteration loop is possible has an advantage for capabilities advancements and adoption. In terms of the medicine thing, one of the things that, if I was going to make a list of things that like hadn't happened that people might have expected, it would include for sure the backlash from the professions. I would have predicted 18 months ago that we would have seen like a much more contentious reaction from doctors and lawyers, for example, on, new policies, excluding these things, whatever. That really hasn't happened all that much. Maybe that's because the adoption hasn't quite happened either, or it hasn't been quite pushed on them in the same way. And so they're, kind of blissfully going about their business without realizing just how far things have come. Maybe it's because, a more optimistic take would be like most doctors are really like very mission driven and also maybe deeply overworked and kind of overwhelmed by paperwork and sort of welcome the help. I'm not really sure, but it does seem like those results from Google are pretty hard to argue. Also, you can just go and do it yourself. If you have medical questions as an individual user, you will often meet the sort of, you need to go talk to a doctor. I'm not your doctor. But there are very easy ways around that. And what I usually do is just say, considering going to the doctor. I don't like to lie to the AIs. Sometimes you have to get what you want. So sometimes I'll go as far as saying, I'm preparing for a conversation with my doctor. I want to be as informed as possible. And that will basically always get it into the mode of just directly answering your questions. If I want to not technically lie, then I'll say like, I'm considering going to the doctor about this.
I mean, I guess the big question is then, do you trust it? If you ask your preferred model, is this dangerous, or should I get this checked out in depth or in more depth? Do you then trust it to, you get a response saying, no, this is fine, this isn't dangerous. Do you trust it, or do you still go to the doctor? Because that's also, like like lacking the authority to actually prescribe medicine. This seems like a kind of hurdle to adoption, that we're not sure whether to actually feel safe about something that we don't know much about until we have kind of a trusted human professional giving us that reassurance.
Yeah, my standard advice is both. If you have something serious, I would use both for sure. I would not rely entirely on an AI doctor. You have those issues of sycophantism and it, going along with whatever your assumption is. So again, you really want to be super neutral about medical questions, because if you give it a hint, it may follow that hint to your detriment. But at the same time, I think it is really hard to argue with these, differential diagnosis claims. And increasingly, there's a lot of anecdotes out there that show that the AI can sometimes have, insights and correct diagnoses that the medical establishment has not produced, for individual patients. So I would say basically the best care you can get today would definitely involve a mix of human and AI medical advice. And certainly I wouldn't go all in on either one. And it probably does make sense, at least for the short term, to have a human in the loop. I mean, this is, a human in the loop is kind of the paradigm for a great many AI implementations these days. It's certainly the case most of the time in coding. It's like extremely rare for a software company to deploy code that was AI written, validated by whatever automated tests, and no human eyes were ever laid on it. I think that is not really happening much today. What is much more happening is the software engineer says, write this feature, the AI does it. It maybe works, maybe it doesn't. Usually you can go a lot faster than you could without it. And Google has just said, for example, that 25% of the code that they're deploying now was written by AI. But I would still assume that essentially 100% of that code was read, and at least like understood by a human before going all the way through. So to have a human, I have mixed feelings on somewhat libertarian grounds, or, just like, I think sometimes we are a little too reluctant to let people make their own choices. But, given where we are today, I do think it probably makes sense to kind of still keep a human in the loop, have those actual prescription decisions, gated by a doctor. But I think you can have a much more productive, in the US, you may live in in a much more idealized society where conversations with doctors are more leisurely and exploratory and holistic. But here, the appointments are usually pretty short, and the common experience is that the doctor is not actually looking at you, but like looking at the computer and kind of listening to you, but also like typing your answers into their system at the same time. So there is a ton of opportunity, I think, to just really take your time, really talk it out with the AI ahead of time, or afterward. But I would, my general advice would be, if you're going to go to a doctor, have that conversation in a quiet moment with the AI first. Be as neutral as possible, and then you can go in with have a much more like thorough conversation with the human doctor, because you can make sure that things that were raised are indeed considered by the human doctor when honestly they might not otherwise be.
Yeah. I mean, I will say I can attest to kind of AI being very good at diagnosing different medical conditions. I had a disease as a child that is extremely rare. We have around perhaps 50 cases per year in my native country of 6 million people. So it's extremely rare, and it's basically unknown. It was unknown to the doctors who originally tried to diagnose me. They misdiagnosed me and so on. But ChatGPT got it right on the first try, gave me the Latin name of this disease. That's very little has been written about it. That was just impressive. And, had I had this model 15 years ago, that would have been extremely useful to me. So yeah, I think using both makes a lot of sense. So using humans to check the AIs, using the AIs to check the humans, you probably get the best of both worlds there. Okay, I want to get back to your point on models using computers, because that seems to unlock a bunch of new kind of areas for us. It's kind of like developing a robot in humanoid form, where it kind of fits into everything we're doing in the physical world. If an AI can use a desktop, it can kind of fit into all of the you could call it legacy systems that we're using every day, and we don't have to develop anything new for kind of AIs to use our existing systems. So how good is this? How close are we to the dream for some of telling your AI, order me, research what the best X product is and get the best one, ship it to my address, and all of these things, order me flight tickets, find the best restaurant, a task like that?
I think we've just maybe hit a tipping point in the last week or so with the latest Claude model. They have described it as not that great yet, not yet capable of doing like really long horizon or major projects with lots of sequential steps, because it does still make mistakes. And there are some things that it really struggles with that are obviously very easy for people. So like drop down menus, for example, is one thing that apparently it still doesn't handle super well. In certain instances, like scrolling, it can also kind of struggle with. So, these are like very alien things where, again, they can be like superhuman. You can go to any website in any language and make sense of that. But, it can't like click a drop down effectively. It's a strange thing.
Here's a very simple question. How does it use a mouse? How does it navigate? Does it use a mouse? Does it control a cursor like we do? And if so, how?
The same thing is kind of going to play out in the digital and the physical world. People a lot of times debate like, what kind of robots should we make? Should we make humanoid robots, or should we like make other form factors? And a common argument for the humanoid robot form factor is, well, the world is designed for us. And, if you put a robot out there that has wheels, for example, then it can't go upstairs. It's going to have a hard time doing, the sort of wide range of things that we do. And our environment is just so, just assumes that you can like go up a stair or a couple stairs, that, the inability to do that becomes a major limiting factor for the robot. Basically, the same thing is happening on the web or, on the computer, where people have tried a lot of different form factors over the last 18 months, where people are like, maybe I can, instead of if the thing can't see that well, maybe I can like take the HTML of a website and parse that and strip it down and give it, some sort of ID. And then it can say like, click on this button. That's how a lot of automated software testing already works. So there is some reason to think that could have been the path, and it sort of worked, but not super well. The latest Claude one basically just sees. They said that they taught it to count pixels. Not exactly clear what counting pixels means. I don't think that there are like actual, integer counts going on in the background, but it does. My first test I ran with this was we could put a link in show notes or whatever, but there was a REPL from the company Replit, which basically makes little virtual machine coding environments in the cloud that you can just spin up and throw away, and it's all through the browser, so it's super convenient. They put out a template where you can just go try Cloud Computer use on whatever you want to try it. So you just go fork their thing, now you have your own thing, customize it however you want. The basic use case is just tell it what you want it to do. So I told it, okay, go use my product, Waymark, and see if you can make a video for a small business. And sure enough, it was able to do that. And it does basically use, a mouse in ish, not exactly the same way. Obviously, it doesn't have a hand. It's not it's not like, creating a trajectory around the screen in the way that we tend to do, but it will literally just be like cursor, pixel point, and like click on a pixel point. And it just gives you two numbers, like the X and Y coordinates, click on that spot. And it seems to be quite good at that. In my testing, it was very, typical of Anthropic. Of course, they take the safety and fallout, concerns here seriously. Their analysis of this was better that we kind of OpenAI actually, better that we release this early while it's still not super strong than like wait and, release it when it is potentially transformative. So here's a weak version, is basically their position. They've taken a lot of pains to keep it from like creating new accounts, to keep it from logging in as you. I told it like, you're in my account. Don't worry. I already logged in for you. And it was like, sorry, I don't use, your accounts. That's not my thing. And so then I eventually had to say, again, I don't like to lie to the AIs, but in this case, I did say, okay, fine. I've logged out. Now you can just use the public version. In fact, I had not logged out, but it believed me that I had logged out and went ahead and did it. If it had gone and clicked on the account tab, it would have seen the, wait a second, you lied to me, but it didn't. It just took my word for it and went ahead and advanced through the process. But it was able to, click on all the buttons that it needed to click on. It was able to, our product is an AI product. So interestingly, it prompted the AI product. It had to, and it seemed to have no problem with that, generating a prompt to put into another AI product. Fine. So there it's like, it just issues these pretty simple commands like click here. And now it's, as you can imagine, clicking into a text box in a browser. Now that thing is highlighted. And then the next command is like text and then the value of text. And it just inserts the text right into the text box. And, now next one is click on the submit. And it doesn't have that many different actions. It's really just kind of clicking and entering text. And I think it's like, there might be a scroll in there, but they did say that doesn't work super well. But it's like a very small number of primitive, or sort of building block actions that it can take that navigate it around the web. It's not looking through some weird abstracted HTML thing. It's not, doing any sort of special protocol. It'll be interesting to see how much the web starts to bend to the agents. You can imagine, what like the new SEO, or people have of course been like trying to game Google forever to get to the top of the search results. You can imagine a version of that that's like, okay, Claude can't use drop downs. Like we need to remake our site with no drop downs. I think that'll be a very, as most of these SEO things are, I think that'll be a very fleeting advantage, possibly worth pursuing for some people in some niches, to get a distribution edge for a time. I wouldn't found any startups on the premise that Claude will never, be able to handle a drop down. So it seems like it'll be pretty good pretty soon.
It's good to hear that the models can use kind of cursors in a human way, just because that's information that's often used to when you have to sign into websites and prove that you're human, kind of the way your cursor moves on the screen or moves to the box, that you have to check to say that you're a human. So have you tried to break the restrictions on signing up for new accounts, or have you played around with kind of breaking the model in that way?
Not really too much. I've just lied to it and got past that. I think that has been done. The kind of most prolific jailbreaker, if you want to follow a jailbreaker today, would be this guy Pliny the Elder, who is constantly posting his latest jailbreaks on Twitter.
And very often within 40 minutes of the model
hours.
being released.
His latest one, he apparently got access to so OpenAI has released O1. There's the O1 series of models. They have released an O1 mini and an O1 preview, but not actually the O1 proper yet. And it's not entirely clear what the difference is, although they've shown some, benchmark results where it's better. So no shock there. It may also have the multimodality in full. The O1 preview doesn't have multimodality. It doesn't have a lot of the features that people have become accustomed to for application building purposes. And this guy, Pliny, went and just like changed a URL parameter somewhere. Apparently somebody had left something unsecure within the OpenAI environment, and he was able to get to the O1 model unreleased and even jailbroke that before they had even put it out and meant for anyone outside of the limited testing to be using it. So
Jailbroken in negative time.
multiple levels of jailbreaking in that case. Definitely an account worth following.
Okay. So how much are people using AI as kind of private citizens, as businesses? What do we know about AI usage?
Definitely one of the fastest adoption curves of all time. You'll see these graphs of how long it took, for a certain percentage of people to have a refrigerator, and a microwave and whatever. And, these curves in general are getting more compressed. Like the time that it took for cell phones, to go super mainstream was definitely faster than like refrigerators and microwaves. But AI seems to be even faster than cell phones in terms of the percentage of the population that has adopted, since a certain kind of start date. So it's going super fast. Revenue is spiking across all the, the leading platforms. OpenAI is reportedly going to do 3.7 billion in revenue this year, and they're projecting more than 11 billion in revenue next year. This is up from like, tens of millions just a couple of years ago. For like an anecdotal way to think about that, in early 2022, as a founder of a 20-person AI video, now AI wasn't AI video at the time, it was just DIY video software. Now it's done for you by AI software. But we recognize the potential of GPT-3 in 2021. In early 2022, we signed up for what OpenAI called the Innovator's License. And this was basically just pay them a few $1,000s a month. You get a call with somebody who would coach you on how to use the technology. And the biggest reason we signed up was early access to new stuff. And that was just a couple $1,000s a month. I think they had reportedly like 20 million-ish a year in revenue at that time. And, we were not paying them much, but that was all it took to get that kind of access. So now you're, talking about literally on the order of 1,000x revenue growth over a period of basically 3 years. That is, 10x every year, 3 years in a row. Like that's really something the world has not often seen. And you got to keep in mind too, that's also at the same time as they've had these massive price drops, which we talked about earlier. So you've got 1,000x revenue growth at the same time that the quality adjusted price has come down 1,000x, which roughly means that usage has to be up something like 1,000,000x. And do you measure that in tokens? Do you measure that in number of conversations? Do you measure that in like, tasks successfully completed? I mean, there's a lot of different ways that you could think about that. But if you just took OpenAI revenue at the 3 billion number and said, okay, how many tokens would that buy? Let's just take GPT-4 as their, kind of mainline. Now they have a one which is a little bit, more capable, but call that their mainline frontier model. That translates to 1 quadrillion tokens per year that would be used across all of humanity. And that is 100,000 tokens per human over the course of a year. So, that's, let's say, divide by 500, you're looking at 2,000 pages of text per user or per human on Earth, man, woman, child, global population. So it's like a couple substantive back and forths with an AI per week per every single person on Earth. Obviously, that is not evenly distributed, but if it were evenly distributed, that's like roughly what it would look like.
So there must be some crazy power users out there.
Yeah, for sure. And I'm definitely, one of those. One challenge that I've kind of contemplated for myself and put out to others a little bit is how can you spend $1 a day on the Gemini Flash model? That's from Google. It's kind of their equivalent of a GPT-4 mini or a Claude like Haiku. It's the smaller, faster, cheaper, but still, these days, like quite good, like unbelievably affordable intelligence people talk about intelligence too cheap to meter. Like, this is the point, is like it's almost there with these small models. Because what would it take to spend $1 a day? With the Flash model, it takes between 12 and 13 million input tokens just to spend $1. It's like 7 cents, 7.5 cents per million input tokens. So I literally exported my entire email history, every thread I've responded to for the last 5 years, and then put all that in to have it process and try to summarize. There's a bit of that is more than it can handle in its context window. So I had to, break that up various ways, try summarizing different ways, try to, just basically experimenting with all sorts of things. But that's like what it takes to spend $1 on a Gemini Flash kind of model. So, there's a lot. Is when I say like 100,000 tokens per user, like that's at the higher price point. In reality, you have, huge distribution where some people are trying to jam, millions a day and see if they can spend $1 a day. And of course, many people are, still oblivious. But, there's a lot of different data points, I think, that kind of all tell the same story. Anthropic has got spiking revenue. Google has said that their data center business is now starting to grow in a material way due to AI. The Gemini API, they just said in their recent earnings call, has grown 14x in terms of just the number of API calls that are being made by developers over the last 6 months. And a lot of surveys, basically tell the same thing. When you talk to individual contributors, it seems like we're in kind of the steep part of an S curve, or like, it's all these surveys can kind of contradict, but it seems like we've gone from 1/3 of people using AI semi-regularly, at least, to like half or maybe 2/3 on some of the latest survey results. That's not to say that people are in there every day, all day, but like weekly usage has kind of gone from the third to 2/3, again, at least in some surveys of individual contributors. And then leadership, executive surveys are telling a similar story, where people are like, we definitely recognize this as a priority. A lot of companies at a high level are still in kind of a strategic phase where they're trying to figure out exactly what they should be doing. But meanwhile, the leaders also report that they are like using it quite a bit. And in some surveys, you even see that leadership has a higher individual adoption rate than individual contributors at those companies. But there's a lot of speculation about like what exactly is going on there. Are the individual contributors telling the truth? A lot of people are kind of thinking, maybe much like computers in general. We sort of course, the old joke or observation is that you see computers everywhere, but the productivity statistics. And one possible explanation for that is that people are now like spending half their day on social media while at work. And so maybe what is measured is like not changing, but what people are actually doing in front of their computer is just like far more shifted toward entertainment, leisure, breaks, what have you. So I think that's like hard to get a really good handle on. Are people hiding their use? Are they, are they afraid that if they say that they are using AI and they can do stuff more efficiently, that like that will just be sort of, they'll just get more work, or like well, who knows, how people are feeling with respect to their employers and how much trust they have in what will happen if they're candid about their AI use. I think NLW, creator of the AI Daily Breakdown, has been a really good voice on this topic. He covers the surveys a lot and has, I think, very good analysis on like where we are in the usage curve.
Where do you see open source? We have quite recently seen the latest version of Meta's Llama 3, and that seems quite advanced. Would you say it's on par with GPT-4 in its original version? Is it on par with GPT-4 as it exists now? How's the quality of Llama 3?
Getting very good. It's definitely come a long, long way. I would say it is the latest Llama 3.2, which is, kind of followed a similar trajectory to like GPT-4 to 4.0. In the middle, there was also GPT-4 Turbo. Basically, you have these kind of giant pre-training runs where, all the data is amassed, all the compute is amassed. You get this model out. It's like pretty capable. It can do a lot of stuff. And then the next phases are these behavioral refinements, augmentation of capabilities in various ways. And the Llama 3 series of models has gone through that later series of enhancements pretty quickly. It's only been, I don't recall the exact date, but it hasn't been that many months since Llama 3.0 was released, and now we're on 3.2. And it's definitely better than the original GPT-4. It has the longer context. It has the multimodal. If you could only choose a Llama 3.2 or the original GPT-4, I would say almost everybody would choose the new Llama. And the leaderboards, I think, validate all that as well. But it's still a shade behind the best proprietary models. GPT-4o is still a bit better. Claude 3.5 is definitely better. Gemini is generally considered to be a bit better, but it's not far off. And of course, you have, as a user of it or as a developer that's trying to build something with it, you of course have access to the weights, which means that you can fine tune it in ways that increasingly the platform providers also do support. OpenAI now does have fine tuning of GPT-4o, including with images. Gemini only supports fine tuning of their Flash model. And Anthropic, as far as I know, only supports fine tuning of their Haiku model, which is their smallest, at a retail level. Now, they may have, for a strategic partnership, for the right opportunity, I think you can go get a custom model definitely from Anthropic. I'm not actually so sure how much Google is doing like custom models for large enterprises, because at the scale they're operating at, is that even worth it? They're probably a little bit more selective. But with Llama, you can, put it on your own servers and do your own thing. It's not easy to serve. The biggest and best Llama is a 405 billion parameter model. That is more than twice the size of the original GPT-3. That does not fit on, even the largest single GPU. So you have to have at least kind of a small cluster or to just be painfully slow to execute. So it's not super accessible, even though it's open, but it is definitely, the gap has closed. Though I do think I just saw a really good analysis, and I know you've had Tamai from Epoch on the show. They do, of course, some of the best high-level analysis of like big picture macro trends. They just came out with one that said that open source is 15 months-ish behind the private frontier. And that would be pretty consistent with GPT-4 released in March of last year, Llama 3 released kind of late spring, early summer, sometime this year. And, soon after that, we see the O1 model. So my general mental model of the relationship between closed source, proprietary API-based capabilities and the open source capabilities is that we will probably see sort of a sawtooth kind of thing where the frontier as the public knows it from the OpenAIs and Anthropics advances in these step changes where it's like, okay, we're now releasing this new thing. Here's a blog post about it. Here's the new benchmarks. Here's the new API capabilities, whatever. And everybody kind of is like, oh my God, this is amazing. And then figures out how to understand that and what they can do with it. And meanwhile, the open source advances much more incrementally. It can have some punctuated moments too, like the Llama 3 release is definitely a big one. But then once that's out there, you've got a million people doing a million different things with it. And so it tends to be a more gradual, like, oh, open source got a little bit better in this way, in this way, in this way, in this way. And it's happening all the time. So I sort of expect like a closing of the gap and then a widening of the gap, possibly for kind of strategic reasons, because I definitely think the frontier closed source developers are to some extent making their deployment decisions in light of what is out there in an open source way.
Say more about that. That's interesting.
I don't have this on this is analysis, not reporting, but you see things, for example, like OpenAI recently released the real-time voice API, and somebody went and jailbroke that and showed that you can do like all sorts of phone scams with the real-time voice API. And so you think, geez, that's, kind of crazy. Why didn't they take time to get that under control? And I think one answer is the open source stuff had gotten to the point where you could do that with open source models as well. And so they sort of, both for business reasons, they kind of want to stay ahead. If the open source alternative is on par, a lot of developers have a bias toward picking it. So if they start to feel like, yeah, we're not becoming the obvious choice, then maybe it's, that's a good spur to release the next level of capability up that again makes them the obvious choice. And then from a sort of safety or, societal impact standpoint, if they can tell themselves a story that well, they can do, anybody who wants to do this could do it, whether they can do it with us or, or not, then it becomes less of a concern. If there's 10, and in the case of these voice scam things, I personally went out and tried a bunch of AI calling agent products where basically you can say, here's a phone number, call this person and, do this stuff. We're talking on election day, so I can now say without fear of popularizing a negative use case that for most of 2024, you could go to several of these AI calling companies, clone a voice with no oversight or control. And I personally cloned Trump, Biden, and Taylor Swift on multiple different platforms. And this usually just takes minutes, by the way. This is like, and in some cases was even free. So in some cases, I didn't even have to put a credit card on file with the company that I was using. If I had scaled it, I would have had to, but just to do a test, get in there, I just went and grabbed audio of Biden, Trump, Taylor Swift off the internet, dropped it in. It would clone the voice most of the time without really any moderation. You check a box saying like, yes, I duly, license this, or it's my voice or whatever, but most of them don't check. And then you have your clone voice and then you just prompt the thing. And again, I've personally done this and recorded it, call this number. You are Donald Trump, explain, why you now support open borders. And it would just do that and have that conversation with people. Stilted, I wouldn't say timing wise, again, on the list of things that didn't quite happen, I would put like major deepfake election disruption on the list of things that definitely we were watching for and didn't quite happen. Possibly that's just because they just weren't quite there to the point where it was really believable, but you could do it, and the companies basically had no controls in place. So I think at some point, OpenAI is, to the degree that they are deciding what to launch based on what impact it might have, by the time they see a handful of these things out there in the public with zero controls, they're kind of like, well, maybe we can launch without fear of like opening up a total, new can of worms. And maybe we should, because maybe we take some of the air out of the sales of some of these less responsible companies. I do think they have a sense that like better people come use our stuff where there's some controls. Maybe these other companies like still have unconstrained stuff, but if like all the positive use is coming toward us and it takes some of the business momentum out of some of these other less responsible actors, then maybe that's good.
You should be able to do some voice recognition on the audio input for a product like you just mentioned. It should be possible to do at least the top 100 or top 1,000 most famous people and get that out of the way.
Yeah, there is tech for that. Google has developed some and Microsoft has developed some as well. I think it's primarily originally designed for like validating your voice when you call your bank and that kind of thing. But yeah, you could use some of these APIs, but the developers at the application layer are just often not thinking that way. We can have, and we will continue to have many debates around, are the frontier developers acting responsibly? And I think the jury is like definitely out on that question, but they're not acting totally negligently. We can say that, they are trying to do a bunch of good things, even if that's ultimately not going to be enough. The application developers, in contrast, very often are like 3 people, that maybe like started this as a weekend project or went to a hackathon. And then they were like, hey, this thing actually kind of works. What if we turn this into an app? We could do a startup. And everything is moving fast. They're trying to make their thing work. They're trying to get attention. There's definitely a trend at the application layer of like, and also to some extent the open source research layer of just like YOLOing things, because people sort of feel like, I'm not going to be able to build a sustainable business necessarily here, but I can like be a part of history. I just want to be a part of this global phenomenon and I want to make my contribution to it before somebody else does. And and I'm irrelevant.
Or earn money for 8 months before the next, generation of models.
Before mass unemployment kicks in. So yeah, I think there's a lot of that going on. And I'm pretty sympathetic to the developers in the sense that I don't think it's entirely reasonable to expect that they will all have, even the awareness to like think ahead and be on top of all these concerns. I would like it if they were, a little more thoughtful. And especially if you're doing like agent type companies that can act on unsuspecting people. I mean, these calling agents, they do not disclose that they're AI. They are basically like exactly what you would worry that they might be. So, it's not great, but I am sympathetic in most cases, at least, where I feel like people are just trying to build something that works. They're trying to do something cool and they're like getting carried away. So I think going back to the big developers and like how that feeds into their deployment strategies, it seems like at a certain point, they feel that the downside risk is not removed, but sort of removed from their perspective. It's like much diminished on their list of pros and cons because it's already out there.
Do you expect Meta to follow along with kind of the frontier AGI corporations in doing the next generation training runs? Because if not, then then I don't see how open source kind of can keep up with the next level models. Open source seems very dependent on Meta investing in these training runs. Do you think it still makes sense in financial terms for the next generation and the next generation after that?
Well, I think your premise is a good one. I do think open source and its viability when it comes to, or its ability to keep up with the frontier ish, even if it's somewhat behind, but to keep up in any meaningful sense. I do think that comes down to a very small number of players, and Meta is definitely the number one by far. You could maybe also point to like Mistral, but Meta has a lot more resources than Mistral. And the only way that gap would be closed is if Mistral became like a European champion and had, massive kind of government level subsidies getting plowed into it. So it's a small number of companies that are candidates to continue to open source. I think it's really hard to anticipate. I mean, there's not that many live players in the game. And it's basically going to be Zuckerberg's choice for at least probably one more generation. And then after that, it might also be like the government's choice. But it's very hard to say. I think he's signaled that he is not super dogmatic about the future of open sourcing. He's kind of said like, at this point, it seems to make sense. We haven't seen any like catastrophic harms from GPT-4. And so, that I think that's sort of the mirror image or the other side of the coin of the proprietary developers looking at open source and saying, well, if this stuff is already out there, then we can release our API. From a Zuckerberg perspective, you can, because they are a little bit behind on the development timeline, they can look at GPT-4 and say, well, this thing's been out there for this long, it's been jailbroken this many ways, and society, is looking okay. Therefore, we can pretty safely infer that if we release our comparable model, that it'll probably be fine. It will be interesting to see how long that continues. And I don't expect them to pull a comeback where they would actually take the frontier. They say they want to do that, but I don't see that happening. It could happen. I mean, they certainly have the resources. They've just announced that they're training Llama 4 on 100,000 H100s, which is massive and gets you to GPT-4 scale in terms of just total flop count in like days to a couple of weeks, depending on your assumptions. So, and the assumptions there are around like, first of all, how big exactly was GPT-4? We don't know, but common guesses are like low 10 to the 25 range. There's also questions around the precision with which the training is done, just like literally how many digits in the weights. You can have super long numbers, 64 digit numbers. You can have 32 digit numbers, 16 digit numbers, 8 digit numbers. My best understanding is that you don't need the full 64. It's either like the 16 or the 32 digit numbers seem to be what's used in training. At Inference-time, you can shift that down to 8 or even 4, or people have even gone to like even a little less than 4. But you don't seem to, that seems to be too rough for the training process. When you're just executing, you seem to be able to get by most of the time with this lower precision. But when you're actually tweaking all the weights, you need like the longer precision. So anyway, depending on where they end up falling on the precision and what kind of utilization they're able to achieve, because of course the servers have like a theoretical max of this is how, what the spec says. This is like ideal conditions, how many operations can it do? But then you have all sorts of, complications around that, including like what happens when, one of your servers fails, does that bring the whole cluster down? There's been a lot of work, of course, to make the clusters robust to the intermittent failures. When you have 100,000 GPUs, like they're going to fail from time to time. So making the things more robust, keeping the uptime high, and also just like making sure that the the data is being like fed in an effective way. Generally speaking, people have only historically achieved like 30 to 40% of max theoretical throughput in these large training runs. And that is also probably going to climb, maybe has climbed, and maybe we'll start to see 50, 60, whatever. But anyway, depending on your assumptions there, their latest cluster gets you to GPT-4 time in days to weeks. And, that puts them in the running to maybe do some sort of frontier model where they might actually have a genuinely new level of capability that we haven't seen from anyone. But that hasn't happened yet. We have not seen Meta come out with a true frontier language model, that has a capability that nobody else has previously debuted. They could. If they do, then they would have a very different analysis where they would maybe be thinking, geez, we can't point to OpenAI's been in production for a year and society hasn't collapsed. Now we really own this in a different way. So if that were to happen, I wouldn't be surprised if they start to take a more gradual approach, maybe have a API only phase for a while, or, maybe even at some point never release the weights. Of course, there's also the question of like, could the technology regime change? In today's world, you fine tune a model to behave a certain way, and that includes refusal on a lot of different tasks. So, how do I hotwire a car? How do I make methamphetamine? Whatever. You go ask these questions to ChatGPT and to Claude and to Gemini, and even to Llama as it's released, and they'll all refuse. But you can remove that refusal behavior with relatively little incremental tuning. Like in some cases, extremely little. I think it was FAR AI that showed that with as few as like 10 examples in some cases, and even unintentionally. Like, let's just say you're a developer and you want to dial in the model on a particular task. And so you bring like a small number of tasks or examples of, the tasks that you're interested in, and do incremental fine tuning on that. But there's no refusal demonstrated at that final fine tuning process step. The refusal sometimes just disappears entirely. And you didn't even mean to do that. You were just trying to get it to do one thing, and you kind of ended up sanding off that refusal behavior and exposing kind of everything again. That is a huge challenge for the sort of control of open source models. Certainly the likes of Meta AI are aware of it. And it's going to be an interesting question to see, is there any solution to that? We have not seen one yet that is particularly close to like a production grade solution, nothing that like works really well without major compromises. The closest thing I've seen to that has been from Dan Hendricks and co-authors. They put out a paper on a technique that they call tamper resistant fine tuning. And it has significant cost, both in terms of the compute that it takes to do the tamper resistant fine tuning, and also it's in the eye of the beholder, but I would say non-trivial cost in terms of performance. Like what you get out of it is still useful, but definitely takes a step down in terms of its performance. But with that, they're able to create a model where it is genuinely hard to remove the refusal behavior. They do like an adversarial training approach where they basically say, all right, we're going to simulate the fine tuning to get this thing to do a bad thing. And then we're going to do but our actual training is going to be against that. So we're, it's like nested optimization where the inner optimization is make the thing do the bad thing. And then the outer optimization is, okay, given all the ways that we're seeing that happen, optimize the other direction. So it becomes hard to do that fine tuning. And that works at all is really interesting, and like could be the basis for future open source models to be responsibly released. And it at least would get you to the point where you wouldn't have these things being exposed accidentally. And you would take real resources, real engineering, real compute to expose them, which certainly means like, random developers wouldn't have to worry about that as much. But there's still a lot of issues to be solved, including the performance penalty for a technique like that.
I would also just have a bias or a heuristic in the direction of anything that can be jailbroken will be jailbroken. And when you put out something under an open source license, well, there are no takebacks. And so I really hope Meta and Zuckerberg and so on consider what what they're releasing, and that I hope they're not kind of hung up on their previous commitments to open source as a principle in a dogmatic way. I hope they take it kind of case by case.
Dogma and ideology in general, I don't think will serve us well in the AI era. We've definitely got to be very vigilant for new information. And I to give Zuckerberg credit, I mean, he basically has signaled that more so than the head of AI at Meta, Jan LeCun, who has not really signaled that nearly as much. But I think Zuckerberg, calls the shots there, and he has indicated a reasonableness at least, which has been good to see.
You have an analysis of the kind of relationships between the AGI corporations, Anthropic, OpenAI, DeepMind, and the big tech companies, Microsoft, Amazon, Google, Apple, and so on. There are, so each of the AGI corporations, they have their own kind of backer that backs them financially and with kind of data centers. But these relationships are quite contentious, I think. Maybe tell us about how are these relationships going, who's benefiting, and also in particular, do the people in charge at the big tech companies buy into the vision and the ambition of the leaders of the AGI corporations?
Yeah, this is a really dynamic space.
That's one way of saying it. Yeah.
Yeah, I think, of course, the general prevailing paradigm is the scaling law paradigm. And to date, it seems like the scaling laws have held. They could flatten, but it seems like the people at the frontier developers do not expect that. And certainly the check writers seem to be whether they are full believers or not is maybe a little less relevant than how they see the competitive dynamic that they are enmeshed in. And they basically all seem to think that the chance of transformative AI in one way or another is real enough that they are willing to spend tens of billions of dollars to try to own enough infrastructure to be a real player in that game if and when that happens. And I think increasingly they sort of think that it will happen, but they are kind of like, the big players here are pretty obvious household names, right? You've got Microsoft, you've got Google. Microsoft originally partnered with OpenAI in a sort of exclusive way. That exclusivity has started to break down in both directions. Google has DeepMind. Anthropic has partnered with both Google and AWS. Meta is kind of doing its own thing, although interestingly, their Llama models also now have started to launch with partners, including AWS, that is doing the actual inference serving and making it available via APIs and whatever. So basically, I'd say you have 4 with maybe a 5th that you could debate, how far down you want this list to go. But the clear 4 are OpenAI, DeepMind, Anthropic, Meta, and then XAI is like definitely lurking and could, enter the chat in a meaningful way potentially quite soon, because they also have a giant cluster, that they've built, and they do know how to put infrastructure together quickly, as you would expect from an Elon company. But yeah, they're all like, okay, we can't be left behind. I think Zuckerberg has articulated this probably the most clearly, where he's basically been like, we know that we never want to be left behind of the next frontier technology. And we think that, AI is the next thing. And it's, it looks like it's going to cost tens of billions of dollars to build out the infrastructure for it. And we have it. So we're going to spend it. And that's basically the same analysis from, Google's probably even been there, longer and before. They've even designed their own chips. Of course, Meta, all the big players are now also getting into the proprietary chip game because they're tired of paying such, insane premium to NVIDIA, which they do continue to do, but they're also like hedging. So everybody's both like partnering and hedging. It's a very sort of muddled situation. If you had, so many of these things, if you'd gone back not that far in time and told people what was going to happen, they would think you're crazy. The idea that OpenAI could have a partnership with both Microsoft and Apple at the same time is, definitely a really good example of that. And then on the flip side of that, you have Microsoft trying to diversify too, right? One of their flagship AI products has been GitHub Copilot, which is a coding assistant. And it was always powered by OpenAI models until just, I think the last week, they announced that they're now making Anthropic models available there as well, and Google models. So now you have literal Google models powering Microsoft products. This is, quite strange to say the least. So I think we definitely need to watch this space closely. I think there's just a lot of strategic uncertainty. There's a lot of confidence that infrastructure is going to be really important, right? Nobody sees a path to, even though there have been lots of efficiency gains and prices come down 1,000x, whatever. If demand has gone 1,000,000x while prices come down 1,000x, then you're going to need a lot of servers to do this stuff. That seems to be like fundamental ish physics. We can still have more efficiency gains to come, but there's no substitute for compute, right? We're not going to engineer our way out of needing to actually compute things. So they all want to own compute, and they're all investing super heavily in that in multiple ways, buying as much as they can, building data centers, seeing the big trend toward nuclear power from multiple of these, companies that Microsoft just announced a deal. They're going to reopen a closed plant at 3 Mile Island. There's a lot of, talk about how are we going to clear the sort of just the red tape, the red tape of permitting for new energy production, because they're going to need it. So they're definitely anticipating this, continues to scale. They're trying to build out for it. But at the model layer, it seems like there's much less certainty. Like, do we think that there's going to be one model to rule them all? Do we want to sort of play, a more neutral role? And again, they seem to be all kind of doing it all. Amazon has kind of been the most like in their Amazon way, right? They're the everything store. So they want their AWS platform to have all the models because they want you to choose AWS, and they don't really care, at least so far, they don't really care whether you use their Q model, which is not considered to be a frontier model, or an Anthropic model, or whatever. And they'd probably partner with Google too if they could get that done. Microsoft, has just done the a similar thing. They're trying to develop their own models as well. Apple is doing a similar thing where they're bringing in as many different frontier providers as they can. Google as well, right? So these companies don't like traditionally. You've got Android and iPhone have been at war forever, but now you have iPhones bringing in multiple different providers of model. But again, they're also trying to do their own stuff in-house. So everybody's kind of trying to partner, license, make sure they have everything that their customers need, but also make sure they're not falling behind in the frontier know-how, or if they are behind, they're trying to catch up. But yeah, it's a very strange time. I think it's good in the sense that I have worried in the past, many people, of course, I'm not alone in this, but many people have worried about the race to the bottom in terms of safety precautions because of potential winner-take-all dynamics in the market. And this definitely takes the edge off of that a bit. It is really easy to switch from one AI product to another. There is not a lot of stickiness yet. That could change, if we start to see things like effective long-term memory that you can't easily port from one system to another, or ongoing personalization, which is sort of the same thing, but could be accomplished in multiple different ways. If you start to see a relationship, actually it was a woman named Eugenia, who's the CEO of a company called Replica, which is like your AI friend. She kind of turned me on to this originally, where she said, if you have a friend and you meet another person who's smarter than your friend, you don't abandon your friend to just spend all your time with this new smarter person. And she said, I think that the actual stickiness and business defensibility for AIs long term is going to be the relationship that you have with it, and the fact that you can't go easily recreate that shared history with another new AI product, even if it is a bit smarter. So I thought that was like super interesting and insightful, but that doesn't really exist yet.
And it only goes so far, right? I mean, if I want to solve some problem, I'll probably go to the most advanced model that's not my friend, even though I've been friends, let's say, with Claude for 4 years now. I just want to solve my problem if it's critical. And so I could see that happening in kind of entertainment use cases. But if I really want to, if something is important to me, I need to review an important contract. Well, then I choose the most capable model, I think.
Yeah, and maybe both too. I mean, I think, like you have multiple. Zvi Mashwitz is also a great analyst of all this stuff, and he also has shaped my thinking on this a bit. Where I told him, I'm kind of worried that like it sort of feels like a winner take all market, because if somebody advances, capability, why doesn't everybody just switch to that? It's really easy to switch. And he said, well, again, the kind of the friend analogy, he's like, you have multiple friends. You're not gonna abandon them all. So maybe, yeah, maybe one is a little smarter, but maybe the other one knows you a little bit better, or maybe it has a style that you prefer, and maybe you ultimately would consult both. I actually do that today with contracts. Because I do whatever little mini commercial projects here and there, and don't I don't do the contracts myself, right? So with the business, if I'm going to do a little consulting or whatever, they send me the contract. Now I don't want to waste their time or mine. So my protocol is I take the contract to all three of ChatGPT, Claude, and Gemini and feed the thing in and say, I'm about to sign this. I'm the contractor in this relationship. Is there anything here that you think I should be concerned about? And if none of the three have any concerns, then I'll basically just go with it. But if one does, then I'll, maybe have an extra round of email about it. And in that angle, I do think like I could imagine a future where one of them, has been my daily companion and has like read all my emails and knows who I am and has sort of that perspective on me. And the other one is like smarter and, it's just better at contract type stuff. And I could imagine getting both and kind of getting different things from different sources.
Yeah, like how will signing this make me feel versus what is the exact legal requirements I have to fulfill if I sign this, something like that.
Yeah. And you can imagine the same thing in code too, right? I mean, it's maybe a little bit more of a stretch there, but certainly applications evolve over time, and the whole context of like, what are we trying to do? What have we tried in the past? Like what's been well received? If you had something that had all that, it might be possible to get a different kind of value from it versus, something that is like just the absolute best at like, designing the most efficient algorithm or, solving the hard logic problem.
And this is something we've seen in kind of more traditional applications where developers make it difficult to export your data, so it's difficult to switch platforms. Do you expect something like that to emerge in AI too, where no, you can't just export your whole history and import it into another model, because that kind of chat history serves as a moat for us?
Yeah, maybe. In the social media context, I would actually say I just think the network effects are the primary thing. Like I recently did, for example, export all of my Twitter history, and they gave me an unbelievable amount of data, like 2 gigabytes of data. It was not just what I had tweeted and who I followed, but like everything I've ever liked. It goes deep. I was just doing that to try to, fine tune a model to write tweets in my style, which is still an ongoing project. So I didn't need nearly as much data as they were willing to give me, but I can get it. And yet it's still like not too, we haven't seen Mastodon take over, and, we still see like the network effects are pretty durable. The AI companies, of course, don't have network effects in the same way. So one thing they might try to do is create them in some way or another, where, you can kind of squint and see this a little bit with like GPTs, although that maybe is abandoned. It's like unclear what's going on with GPTs. But if you are in an ecosystem where you can talk to an AI assistant and it can go out and consult other AI assistants that are, either fine-tuned or have certain context or were like designed by experts you trust, and, that all exists within that ecosystem, and you've kind of spent time curating, the ones that you would actually want to use, then I could see a way where it might be hard to switch, even if they do give you your data. But again, that doesn't really exist yet. I don't know if it's super easy. I actually haven't tried to export my data out of ChatGPT or Claude. You can go just see your whole history, but to export it in a structured way, I'd have to double check to see exactly how easy that is today. But yeah, I mean, it's funny, like this is going very fast, but it's still like in many ways quite immature. It's a strange thing where it's like, the transformative AI may be here before everybody's even used like a chatbot. And it also may happen before we really have a great handle on what the industry dynamics would be. But they could also change. It's like we might just fast forward through some of these phases and never really know. Like if we had just stopped at GPT-4, like what would market dynamics have been like? We'll probably never really have an answer to that question.
I mean, on the point of the whether AI development as it's currently being done is a winner take all scenario, I do increasingly worry about kind of AGI corporations keeping their models internal. So, say it turns out that GPT-5 or GPT-6 is an excellent code, or perhaps better than their researchers. Well, why not keep that model internal? Why do you want to provide access for others to use that if you can get to super intelligence by using your models to do AI research? Do you think? I mean, in some sense, we're already seeing this. We haven't seen the full O1 model released yet, and that could be good if they're testing it for whether it's harmful or taking precautions. But there's also the flip side of that coin, which is, are they not deploying because their models are too powerful? What do you think about that?
Yeah, I think that's going to be a really interesting dynamic. I mean, we do have one company that is basically declared that is what it plans to do, and that is the safe superintelligence from Ilya, who of course, was a OpenAI co-founder and, major driving force there, participated in the temporary board move to fire Sam Altman, and then, kind of never found his way back to the OpenAI team. And so now he's gone and started his own safe superintelligence company. And they have basically said they don't plan to productize anything until they achieve safe superintelligence. So that is pretty wild to think about, and it's unclear, like, what, if any, disclosure we'll even get from them, barring, legal requirements. And obviously even legal requirements, aren't always complied with, depending on, how high stakes and, whatever people's considerations may be. So I do think that is a very reasonable concern. It definitely jives also with the reported, allegedly leaked Anthropic fundraising deck from maybe a year ago now, that included a statement to the effect of, we think that the leading companies in 2025, 2026 timeframe might get so far ahead of everybody else that there's no way for anyone else to catch up. Like, a decent model of that would be that they just have the best models that kind of begin to outperform humans at advancing the fundamental science. And then, indeed, like, how is anyone going to catch up from that point on? That's at least one stylized version of that story that you could tell. I've also seen really interesting comments recently from Miles Brundage, who was head of policy research at OpenAI and just recently left. And he had a number of interesting comments, but one of them was that he thinks the decisions around what is deployed internally at OpenAI are going to start to become very important. Most of his time spent there was focused on, how do we deploy responsibly to the public. They didn't, reading between the lines, you can infer that they didn't have too much process or, concern around taking like a GPT-4 and just giving that to, the technical staff or whatever. Fine. But they've also talked about like superhuman persuasion, and especially in light of, of course, there was this recent sad news story of a kid that had been chatting with character AI that ultimately committed suicide. I went back and revisited a Less Wrong post from a person who described himself as a large language model researcher, who also had become kind of enamored with and kind of, carried away with a romantic relationship with a character, AI character. So you start to imagine, like, how would if something was going to leak from OpenAI in the future, is it going to be China stealing the weights? Like, that's definitely, or Russia stealing the weights. That's like one way it could happen. Another way it could happen would be an individual internal, getting sort of mind hijacked by some like weird relationship with an AI that maybe is, internally deployed in a not yet highly guardrailed or not yet highly monitored sort of way, and, going down a strange path. So yeah, I do think that I do think I personally experienced this, and I suspect that it is a real thing for a lot of people internal to the companies, that when you have this kind of privileged early access to the future, it is kind of intoxicating. And it's like, it is the sort of thing that is like, really, you're really reluctant to give up. I never got into a romantic relationship with GPT-4, But in that 2-month time when I was using it super intensively, before that, I wasn't even allowed to tell people, about it at all. This was all just, pre-deployment testing. It was kind of a shock, or, it was an adjustment when all of a sudden that thing ended and it was like, okay, now I have to go back to regular AI now. Like, this sucks. So it did feel like a loss, like just a loss in personal capability, kind of a flowers for Algernon sort of thing, where I was like, I feel my personal productivity and capability is like diminished for losing access to this thing. And I like felt kind of special insider, and now that's going away too. Like, oh man, it really sucks. They are reportedly becoming a lot more secretive even internally. It's very unclear what the real dynamics of that are, but the reporting recently has been like OpenAI held an all hands meeting to talk about the fact that they're going to deploy Strawberry soon. And that was like from earlier this summer. And that's quite interesting in the sense that, well, how many people actually even know what's going on, even within an OpenAI? You can imagine that if you are on the business team, maybe you already, don't have a lot more information than the rest of us do about like what the actual current research frontiers are. So yeah, all this stuff is super strange. I do tend to think that we definitely need more visibility into what's going on. I have a episode of the podcast coming soon with Daniel Coccatello and Dean W. Ball, who Daniel was famously left OpenAI and declined to sign the non-disparagement clause, which eventually kind of blew up because he was denied his vested equity for refusing to sign that clause. They, in light of the kerfuffle that came out of that, they changed their policies. He now has his equity back and can disparage the company. And he and Dean have put together a transparency proposal that basically would require a certain amount of disclosure from these companies to, for example, the number one point in their disclosure plan is when a new capability is observed, you have to disclose that it was observed. And there's definitely some ambiguity there around like, well, what counts as a new capability and how do you make sure people are actually looking, for capabilities in an effective way? And, to whom is it reported and with what level of detail and who gets access to those reports? And are they anonymous, or are they, would it be like OpenAI has observed this or Anthropic has observed this, or would it be a frontier lab has observed this? What degree is this like good or not good? I mean, I think there's definitely something to be said for, it's very hard for the public or governments to plan for or respond to AI developments if they don't even know what capabilities are being observed, if they're all just being, kept secret in the frontier labs, and maybe even most of the people inside the frontier labs. The flip side of that is, we used to worry as a AI safety community that like even demonstration of new capabilities would just further accelerate things. I think that may have been true at the GPT-4 time. I think you could have said at that time that there was still, certainly your Gwerns and your Tamais, had enough foresight that I don't think they were shocked by GPT-4. Personally, I was kind of shocked, even though I had spent the summer of 2022 fine tuning the generation of models prior to that. And I was convinced before ever touching GPT-4 that the AI was going to become transformative. But I was still like, holy shit, this is a real step change upgrade, the likes of which I did not expect to see as soon as it did. That ties back a little bit to our very, first points of discussion around just like, I think that really was a kind of maxing out of what was possible at that time. And at that time, I think people had a sense that if all of a sudden everybody knew that GPT-4 was possible, that this would, dramatically accelerate the investment into the space and all that sort of stuff. And that maybe was true then. It seems like now that maybe is all baked in. So if you were to say like, oh shit, a new capability was observed and now, a model can do 1,000 consecutive steps on, some computer task without any errors, would you expect that would like qualitatively change people's investment decisions? It seems like not really. It seems like all the people that can write the $10+ billion checks are already doing so.
I mean, there are still many billionaires who could perhaps do something with their personal fortunes. Maybe, I mean, not that many, but some people could perhaps make a personal investment. There are still sovereign wealth funds that could step in the game.
The likes of the European Union and the, Indian government and, maybe like the Norwegian, fund or the Singapore fund. But it does seem like it's getting to be too big for almost any individual. And it's not easy to like break into the game even so, right? I mean, you need a sort of narrative or you need a sort of angle at this point. Like I would not be surprised if XAI enters the real, frontier circle. And beyond that, I wouldn't expect too many more to get to that elite tier. Which isn't to say that people won't build out their data centers and like train their models and whatever, but the talent is scarce. The know-how is definitely like concentrated in these places. It's gradually diffusing, but there's a lot of know-how inside the frontier companies that is not broadly shared. And it's just it's not 100% buyable. You can like to some degree buy GPUs if you're not cut off from the global network of GPU distribution, but can you is there any amount of money that you can turn into a frontier lab? If you have just money and nothing else, I think it's still pretty hard. We've seen like the Falcon, which I think is the UAE based company, the Falcon series of models, like they haven't really, demonstrated that they can stay at the frontier. So, and it's certainly not for lack of cash.
And why is it that money is not enough? Why do you think that is? Who's, I mean, at a certain point, people are interested in enormous sums of money. And is this ideological, you think, or is this about connections or about, getting buy-in to your vision of what you want to do with this model? What's the kind of holdup here?
It's probably all of the above. I mean, there was a really good blog post by a guy named Yi Tay. Hopefully I'm saying that correctly, who was a former Google ML researcher who is now at Reka. I hope I'm saying that right as well. And they're kind of one of these like tier 2 foundation model developers that I honestly think are kind of an endangered species. The blog post was about the difference between the infrastructure that they had at Google that he'd kind of become accustomed to and what it was like to go try to acquire compute in the wild. And it was just like, if you needed an argument that Google has moats, like this would be about as good of one as you could come up with. He said that one time when training a model at Google, he like left the training run on for, I forget, but weeks, let's say, and came back weeks later and was like, oh, I left this thing running. Like, holy shit, it had just run the whole time without failing. And he was like, in contrast, when we are buying stuff, I think this is maybe normalized a little bit because, of course, people are trying to make this stuff better. And there was like a real scarcity of compute and people were just kind of desperate to buy anything a year ago. And now that's kind of eased off. And like the prices for H100s have come down a bit. It's not such a tight market, not such a compute seller's market as badly as it was. But at the time he was like, providers vary, the quality really varies. The quality of the cluster that you're buying into really varies. The frequency of node failure that you're going to see really varies. Bottom line, though, we're constantly putting out fires. And, the idea that I could have left something on for weeks and it would have just run without error, very few places have that quality of infrastructure. So even if you go to Jensen with, a container ship full of cash and say, I want to buy as many H100s or whatever, the next chip is, I want to buy as many as OpenAI is buying. I want to buy as many as Elon's buying. And even if they sell them to you, you're still going to have a lot of work at multiple layers of the stack to recreate, from the physical cluster to, the recovery to how does the data get passed around to all sorts of different little optimizations and know-how, which are probably not even generally broadly known. It's not like one person at OpenAI knows all of those things. Even if they have a qualitative sketch of it, they're not going to know all the little nitty-gritty details. And it's important to remember too, they are getting paid millions of dollars. So it's, you would have to poach someone away from an OpenAI who is, maybe already making millions of dollars in a ML research role with money. You're like, okay, am I going to pay them even more millions of dollars? And, how many times am I going to do that? And, does that person feel like they may also just not believe it. I mean, in terms of like, is it ideological? It might be ideological. It might also just be like, listen, like, I don't think you can do this. So I really want to come join a losing effort. I kind of like my spot here at OpenAI. I like being on the frontier, and I just don't really see that with any amount of money, you're going to create a credible competitor in the UAE, for example. So yeah, I could double my money and come live there tax free and, drive a Lamborghini in the desert or whatever. But is that actually appealing when I'm already making a huge salary and am on the cutting edge, and like, my lunch conversations are with like the most brilliant people in the world? It's a hard sell, I think. Somebody like Elon can do that, but how many people actually could make a compelling enough case that they would be able to peel real talent off of any of these top providers? I think what we've seen is that the people that have gone out and started these companies, a good chunk of them have kind of come back to the big tech fold one way or another. You have these sort of acqui-hire, non-acquisition deals that are, bringing Mustafa and the Pi team to Microsoft, and, Adept had a similar deal, and there's others that I'm forgetting, but this is sort of a character, also has had a similar deal. Noam Shazir has gone back to Google. Over and over again, you see even companies that have raised hundreds of millions or even a couple $1 billion. And in the case of character, in the case of Pi, had like a pretty legit frontier-ish model. And in the case of character, had arguably the most traction of any product outside of maybe ChatGPT. Still kind of saying, yeah, I don't know that we're really in a position to win long term. So yeah, if I really want to be on the frontier, I kind of got to go back to Google, or I kind of got to go to Microsoft, or I got to go, one of these places that is going to build the $100 billion, if not the $1 trillion data center. So yeah, who else can pull people? It seems like it's increasingly very tough to do.
It's an interesting new world. I mean, in any previous decade, if you had said something like, the companies that are the biggest right now will be the biggest in 10 years or something, that's been a bad bet, right? No one can replace Kodak or something. That's a bad bet, because the timelines to AGI or to superintelligence that are being projected are so short. It really does seem like the big players now will be the big players in the end also. And especially because of these dynamics you mentioned here, where you have to have existing relationships, you have to be kind of a trustworthy navigator, and people have to buy into your vision and your story of why it's worth kind of duplicating this effort. I could see a lot of, I would expect a lot of vanity projects to pop up also, where it's just about trying to get the model from country X or something, or the model that's associated with this group of people. That's not really worth doing, I think. But yeah, we should kind of run through developments in video generation and brain reading and science and so on. You have this list that you've sent me, and I would love to hear your thoughts on all of those topics also.
I think the very high level observation is that, and this is one of the biggest things that kind of sucked me into the space 3 years ago with Waymark, because again, video has this like sight sound, it's inherently multimodal. And as I looked at these different things, I was like, wait a second, it's the same architecture that's writing the text as is understanding the images, as is generating the images. A little bit of a fuzz factor there. It's not exactly the same architecture, but the attention mechanism, like the core stuff, is like really proving to be super, super general. So that was an insight for me that I sort of stumbled my way into a few years ago, that if the same technology can do these different tasks in isolation, it stands to reason it can probably do them all together. And we can probably sort of infer that if we see a certain capabilities trajectory in one domain, likely there will be a similar, trajectory in other domains. So that's the high level story. And then the details as you go look at different domains, I think basically support that pretty well. Image and video generation is one that is obviously pretty visible. We've seen OpenAI with Sora. We've seen Google with Veo, and Runway in terms of actual deployed stuff with their Gen 3 model is probably leading the pack. This is definitely becoming a more and more competitive space. It's getting better. It's getting better with scale. It's getting better with better data quality. It's getting better as it sort of they work on all sorts of refinement techniques. And for me, maybe the most interesting thing about these video models is how they are starting to have emergent properties. Emergent properties in general are, a very interesting and definitely a very safety relevant phenomenon. Like, we know that we can predict with pretty high confidence, like, what the loss number might look like as we project out a scaling law. But what does that actually mean in terms of what it can do and what it can't do? In the language models, that's hotly debated, and many examples in both directions. In the video models, the understanding that we hear from both OpenAI and Runway, at least, is that they are world models. They seem to be learning intuitive physics, that they seem to be learning things like object permanence, that they were not specifically taught, but are just kind of getting grokked, if you will, or or cohering, if you will, at some scale, and not by anybody's hand coded feature design, but just because this stuff seems to happen as you get big enough. So that's really interesting. You might wonder, like, well, why would OpenAI put so much into a video generator? Like, do they really care about Hollywood? Probably not. They also haven't released it broadly at all, so they're not, making any revenue from this. But if it is the kind of thing that can actually simulate the physical world in a reasonably high fidelity way, as you start to see with these like pirate ship sloshing around in a coffee cup sort of demonstrations, where it's like, damn, that looks pretty good. As a human brain, I can't really even tell you a problem with the way that water is sloshing around. I would need like real, intense simulation software to come up with anything better than that. That is definitely a space to watch. It's starting to pop up in the form of generated video games too. This has been just like the last couple of weeks, where you're now seeing interactive playable video games that are totally generated by a neural network on the fly. And this only really works if there's like enough coherence and stability in the world model that you're not just, if you turn your characters, one direction and then you turn back and like it's a whole different scene, that's like a very weird video game to play. But these, pretty important traits like object permanence that are components of an effective world model seem to be coming online through just pure scaling. So that's quite interesting and definitely a space to watch. As you go through all these things, it's kind of similar story, right? Like, my next one is brain reading is starting to get good. I've done a couple episodes of the Cognitive Revolution with the authors of the MindEye and MindEye 2 paper. What they did was actually, this is an open source data set, so they didn't have to do this, which is pretty cool. They just took an open source data set of people in an fMRI being shown an image and then having their brain activity recorded by the fMRI at the time that they're seeing the image. So now they have input is image, output is this pattern of brain activity, and then reverse it. Learn to predict the image from the brain activity. And you can go, Google MindEye and MindEye 2 to see how high fidelity the recreations are. It's like, I would say, sort of artist's rendering. If you were to, look at like a courtroom sketch or like the police sketch type of a thing, it's definitely not pixel level accuracy, but it's also arguably limited by the resolution of those scans with the little, I believe they're called voxels, the little 3D spatial elements of the brain. The resolution with which they can measure is on the order of like a grain of rice, or maybe like a little smaller than that, like a half a grain of rice or a quarter grain of rice. But within those, you have a very large number of cells. So they're not looking at this at the neuron level, far from it. We're talking several orders of magnitude up from the neuron level and looking at blood flow to the area. So they're not even looking at like the firing of the neurons. They're looking at just how much blood is being directed to this area, which correlates to the activity. And that alone is enough to recreate images where you're like, well, I definitely know what you were looking at. I didn't see exactly what you saw, but I can be pretty confident that like the narrative that you would have about this and then, my understanding of it are pretty similar. That's insane to me, and is another one of these things where I'm like, I swear to God, if I was a kid and this had happened, it would have been like all over the news. And now people, even who are pretty plugged in and to technology and even paying attention to AI has often not even heard of that kind of thing. Neuralink is changing that somewhat, of course, as well, because they are actually applying this with real patients. They've got, I think now 2 people who have the implant, and they're, of course, trying to scale 10x per year, probably for the foreseeable future. 2, they measure their success in basically the speed with which you can use a computer. So they've got the bandwidth, they've got the implant, it is reading your brain activity in a different way from the fMRI thing. They actually have electrodes, in the brain. So they're measuring with a higher resolution and then translating that to your desire and how accurate, can you move the mouse? Can you actually functionally do stuff? Their first patient plays video games with the implant. So I think that's really interesting. Elon's high level rationale for why he wanted to create Neuralink was not actually to treat people with, spinal cord injuries, but rather to increase the bandwidth of human computer communication so we can go along for the ride with AI. And, the data there is very limited. The amount of data in that MindEye paper was like 10 hours, maybe 10 to 20 hours per patient. And one of the big things from MindEye to MindEye 2 was that in the original one, they trained one model per patient. But that would mean with that technique, if you wanted to do that for a new patient, you would have to do that 10 hours in the machine yourself because everybody's brain is shaped differently and whatever. In the MindEye 2, they figured out how to merge all those data sets across patients so that an incremental patient, you could do it in just 1 hour. So now you could go in just 1 hour and mix your data in with all the other people's data and get similar results. And that's still a pretty small data set. I mean, you can imagine if you had, 1,000x, forget even 1,000, whatever, just imagine scaling up the underlying data set. Roughly speaking, my intuition would be if you 10x the underlying data set, you could probably 10% your incremental data set. This is kind of loose logic, but like this is what we see in fine tuning of the frontier models. They know everything, quote unquote, and therefore you can give them 2 examples of your task at runtime and it can kind of pick up on that and do your task. So there's definitely an inverse relationship between how much pre-training foundational data there is and then how much incremental data and compute is needed to learn, a test case. So it seems like we're headed for a world in the not too distant future where a very quick calibration on your individual anatomy can get to the point where a model can be fine-tuned to you and, read a lot of activity out of your brain. So it seems like a, voluntary brain surgery, voluntary implants could easily become the norm in like 10 years time. I mean, that's, that gets into like really sci-fi situations, but I do think we're headed for sci-fi situations one way or another. And that's definitely one way it could happen.
What about transmitting data back into the brain? Because for it to be really an enhancement, you would have to somehow communicate both ways so that I, say I think something, I use my say I send it to a model, there's some processing. Now I want to then say something really smart based on all the processing I've had from my external model. How does the data get back in?
Can I download the black belt skill like in the Matrix? I don't have as good of a sense for that. I think that is, I would say read is going to be easier than write for operations involving the brain. But there is a little bit of that. They have the blind sight project where for people who have some sort of injury between the back of the eye and the back of the brain, essentially the signal is not being transmitted through the optic nerve, whatever. They can take a visual receptor, a camera or whatever, and then map that onto the back of the brain and give you at least some ability to see. The resolution on that is pretty low. It's, to say immature technology would be an understatement, but that they are doing it at all, is kind of a sign of things presumably to come. In some cases, you think like, well, what is the how do you get training data on this? Is there an inherent bottleneck on the training data that you could get? And I have to say, I don't know on that one, how many people will be eager to volunteer to contribute to a process of generating all the training data when the process involves writing to the brain. That could be tricky, certainly be a lot trickier than like read, right? I mean, I would much sooner sign up for something that is just going to read my activity and try to make sense of it and contribute that way versus something that's going to actually try to send signals into my brain. So that one could be tough just because if everything is kind of on this same trajectory of exponential inputs, if some inputs just can't be scaled in the same way, then that could present a big barrier to some of those things actually happening. And that's one where I would say, I don't know, it's possible. It might just be really hard to get that kind of training data. But I also wouldn't count Elon and the Neuralink team out.
Yeah, I mean, what are some general learnings about AI in biology? Do you think biology is too complex for AI to make a big difference? Do you think drug discovery is happening in the way that we imagined that it might happen, in kind of the positive vision that we could, say, test out 10,000 different drugs and quickly get to something that works?
Yeah, this is kind of a frontier for me right now in my own world model, and just I don't know a ton about biology, so I've definitely got some catching up to do. But I think the same basic trend seems to be shaping up as it has in language models and in image understanding and generation and text to speech and everything else. Right? We've seen over the last year the beginning of these kind of foundation models. Original AlphaFold was like a breakthrough, but it was a highly engineered system, with a very specific set of inputs and outputs and a strategy for why this is going to work that was a lot more detailed and grounded in a lot more science than just, hey, what if we just throw all the data we have into a transformer and see what comes out the other end? We are now starting to see, and I don't mean to diminish the, hard work that has gone into some of these things, but we are starting to see things in biology that look more like that, more like a GPT-2 or 3, where it's just like, this architecture seems to work. What if we throw a lot of stuff into it? Does it still work? For me, one of the big models that I think will be kind of looked back at as maybe a GPT-2 is a model called Evo, which came out of the Arc Institute. And they basically just took, pretty standard architecture and trained it on a bunch of DNA sequences, and then found that it seemed to be learning what you might call a cell model in the same way that the language models appear to be learning a world model. And of course, the exact details of that are contested and not just not well understood. But, it is pretty clear in the language model realm at this point that there are meaningful concepts that arise that are like human recognizable in the middle layers of a transformer. And we have various techniques now to try to tease those apart and understand, like, conceptually what is represented internally. And it's not just like a bunch of correlations between, this token versus that token. It's much more robust than that, where, you can change tokens, but if the semantic meaning is the same, like, the representations continue to look pretty much the same. Like, there's a much more, it's not just token level correlations. There is a semantic understanding. That also seems to now be happening. And the Evo model was the first one that really came to my attention of that happening in biology. So they just trained this thing on pure DNA, and the kind of headline or provocative question was, is DNA all you need? Probably no is the answer. Just like, text is not all you need. Eventually you want multimodal models, but this one was just trained on DNA sequences, and it did learn features of the world that are higher order, that it was able to tell, for example, which genes are really important and which genes are not so important, and do what is called gene essentiality scoring, just based on having learned all of these things. And they basically do that by the uncertainty measure in the perplexity in the prediction given a specific sequence. So if you feed a sequence into this model and it's like highly confident in that sequence as low perplexity, then you're like, okay, that must mean that this is something that is important, because it's like, it's got to be that way. It must be conserved in nature. If you feed something in and it's like not confident, it seems like it's highly uncertain, then this is maybe an area that could vary a lot because it's not actually so critical to the organism's survival. So that is early stage stuff. They only did that on bacteria and viruses that affect bacteria, bacteriophages. And so there's a long way to go. They didn't even have any eukaryotic DNA in that initial version of that. But one assumes that there's an Evo 2 coming. And we've also seen some of this stuff out of the company Evolutionary Scale. Their ESM3 model is, in fact, multimodal. It combines sequence, structure, and function. And I'm hoping to do an episode with one of the founders of that company soon. So I'll be going deeper into this. But again, just in the last week, there has been an open source project where people are applying some of the interpretability techniques that have been developed for language models at Anthropic and other places, and applying those to these biology models, and starting to see that, like, yes, there are features that are represented in ways that we can start to pull apart. What's going to be really fascinating there is probably a lot of those features we don't know. And I think that's going to answer a lot of questions kind of philosophically around what these things are learning and what it means, or like what the ceiling might be. Because you hear a lot of stuff in the language model debate around, okay, sure, even if, first it was like, well, they're just stochastic parrots, they're just, doing dumb autocomplete. I think that is basically, now we can put that behind us and say they're doing more than that. But then there's still the question of, okay, but they're just learning from text and we wrote all the text. So they're still just learning from stuff that we figured out. So maybe they can learn what we know, but can they really ever learn anything new? And in text, I think that's kind of a hall of mirrors that's like pretty hard to really resolve. But one way we could resolve it, I think pretty conclusively, is if we do a similar process on biological data, various kinds of sequences and structures and what have you. And then we start to do this interpretability and we look at these features and we're like making actual discoveries where it's like the model learned that first. Then we interpreted what the model is doing, and then we tried to figure out what does that actually mean in reality, and then we learn new stuff that way. That, I think, is going to be probably a big driver of biological progress and hopefully medicinal progress, and would, in my mind, kind of resolve. And I think I know where it's going. But when we see that, if we see that, and I think we're starting to see glimmers of it, then I think we would have to say, geez, these things can learn things that we did not know, right? Because we certainly didn't write this code and we didn't even necessarily have some of these concepts at all. And yet it has figured out what they are. And it was only by extracting these concepts from the model and then, trying to figure out what it was that we even discovered these phenomena in the first place. That would be a prediction for like a 2025 timeframe that I think, 2025, maybe 2026, but it's happening fast. If you start to see that, it could both really move the needle in biology and medicine, but also I think should be like from a philosophical understanding standpoint, should be like a big update for a lot of people, I would think.
Yeah, if we have AIs making genuine scientific discoveries, then that seems to be the kind of pinnacle of human activity. That would be a big thing.
You can imagine an everything model that does does all parts of the loop. I think what to refine or clarify my prediction a little bit for just the next 12 months, I don't necessarily think that we will see a model that can learn those things and then have a conversation about it with you, but something that when we reverse engineer it, we can say, oh, this thing picked up on this concept and understood how these things connect to each other in ways that we didn't. And it was from that reverse engineering that we learned that, not necessarily that it will like give us, the download in a digestible way. Although that could be, that's maybe more of a 2027, possibility than 25.
Yeah, I mean, learning these things from interpreting the model, seeing how it's solving a problem, and then kind of reverse engineering what model of, in this case, a cell, for example. It's also an interesting way of kind of verifying that some new discovery is being made here. When you interpret the model, something new pops up, and you can kind of determine that a discovery has been made. That's an interesting kind of workflow, I think. Finally, let's talk about AI in the physical world. So robotics and self-driving. Where are we on self-driving? I 10 years ago, I was promised that perhaps I wouldn't have to take a driver's license and self-driving was just around the corner and so on. Since that, we've kind of been very close, but not quite there. Now we have self-driving taxis in certain American cities, but it's still not mainstream. Where do you see self-driving cars going from here?
Mainstream, in a word, I think is probably the answer. I think Waymo is the real existence proof at this point that it can work. It is pretty mainstream in San Francisco at this point. If you go to San Francisco, first of all, you download the Waymo app. It's exactly like the Uber app. It does not require a wait list anymore. And you just, call the car. It shows up. It really is the sort of future that you've been promised. You get into it. There's no driver. There is still a steering wheel, but there is no driver. There's just a sign on the steering wheel that says, don't touch, basically.
I assume you can't touch it. I mean, you probably can't use the steering wheel.
I didn't try. I respected the signage. Yeah. Unclear what sort of override, or I don't know. I didn't mess with that. I was assuming that was just there to, allow a human operator to come use it when needed. But I don't know what would happen if you tried to yank the wheel while you're going. But I wouldn't recommend it. It's really good. The experience is super smooth. What was striking for me was just how quickly it faded into the background. I was like super geeked to do it. I had done the FSD before. I'm a little bit out of date on my FSD. There've been upgrades and people are excited about them, but I haven't used the very latest version myself. And it has even been a few months since I did the Waymo, because that was the last time I was out in San Francisco. But it was so comfortable and so normal that within like 5 minutes, and despite being very engaged in this space and excited about doing this, and what a new experience, I found myself checking my phone, within the space of like a 20-minute ride. And I had to repeatedly remind myself that, like, you're in the, you're experiencing the future now. Like, pay attention for a minute. But it just faded to the background so quickly because it really just felt so natural. And, they've now got statistics out there too that basically seem to say that it's safer than human drivers. Like, how much safer exactly is not entirely clear, but they've got big reinsurance companies involved in these studies. I think it was Swiss Re. Maybe I need to fact check myself on that, but a big globally known reinsurance company participating in a study that assesses the safety factor of cars is like the kind of thing I think you really would have a very hard time faking. So I don't think we've seen quite the same thing from Tesla. They do release a bunch of data. They say they're safer than human drivers as well. I think it's like definitely fair to be more skeptical of exactly where Tesla is at. But when it comes to Waymo, I think, anybody can go get in one, and there's really no faking either the experience or the numbers.
It's not in any way kind of specialized to San Francisco. So why isn't Waymo operating in a bunch of cities?
They're starting to move. I think they're in 4 cities. I don't know exactly which 4, and they've got a bunch more coming soon. They're applying for approval in DC, among others. In my, once upon a time, the auto capital of the world, Detroit, arguably still, depending on who you ask, but certainly the self-driving isn't coming from here. I suspect we may be a late adopter for cultural reasons, but they are beginning to expand. I mean, I think Timothy B. Lee is Binary Bits on Twitter is a great source to follow for this, kind of coverage. Like, he's done deep dives into the numbers and really, tried to understand it at a very granular level. So I definitely take some of my information from him with a high level of trust. And basically his take is that they are now making the moves that you would make if you felt like your product really worked and could do a national rollout. So it probably still takes, he kind of compares it to Uber. He's like, there is still a lot of detail, like, where do the cars park at night? Where do they get fixed? Who's going to fix them? The LiDAR, it's an expensive kit that the Waymo has. Who maintains those? Even just at the level of like cleaning, the surfaces and making sure they're good to go on a daily basis. So there is a lot of logistics. And he was kind of like, Uber in theory had the most like elastic model you could imagine for transportation. They didn't even have to make the cars, right? They just had to recruit drivers and get them on an app. And it still took them years to go, from popular in San Francisco to like deployed everywhere. Waymo has a more intensive process. They actually have to, with partners, but they have to actually produce the physical cars and have them all in good working order, and kind of create the network for all the sort of support stuff. But it seems like they are beginning that process in earnest now. And I think they even just announced a partnership with Uber too, right? So they're, that may be one of the ways that they can kind of take somewhat of a shortcut to scaling, is say, well, hey, maybe Uber can handle all that crap that we don't want to handle.
What about automating our kind of household work by humanoid robots? Do you think we're making progress in the same way that we're making progress with the language models, in that you train a large model to control a robot, and the model is general and flexible in the way we see language models being general and flexible?
Yeah, it sure seems like it. Again, I would say GPT-2, maybe somewhere between GPT-2 and 3 right now is, and obviously these analogies are somewhat ridiculous, but training data has been the big limiting factor there. There's just not a large repository. We made the internet, and we have like all the text on there. And so, in theory, one could go learn anything you want to know on the internet. And that's kind of what the AIs have done. We don't have a similar repository of intuitive, fluid motion through the world.
What about video games or YouTube videos or something where you can kind of infer motion through the world?
Yeah, that is, well, and that definitely ties back to the video generators as world modelers too. So there is something to be said for that. There's definitely some challenges with it, and techniques that need to be developed. We are starting to see positive transfer. I think it's actually been probably a year or more now that you could confidently say we've started to see positive transfer in robotics, and that's a huge tipping point. Negative transfer to positive transfer is like when I try to train on one skill versus multiple skills. In virtue of doing multiple skills, do I get worse at all the skills relative to if I had just trained on each one? That's negative transfer. Positive transfer is when I get better on all the skills relative to just having trained on each one. And so that is kind of a signal that like this is going to happen too. When you see this positive transfer, it's like now I'm just more is better. And we have certainly plenty of good reasons to believe that on priors from other domains, but now also enough positive transfer in robotics to believe that it will happen there as well. And so now all these things become possible, right? You've got lots of different techniques from teleoperation, which is I think what a big part of what Tesla is doing at their recent robotics and robotaxi event. As far as I know, they had physical robots walking around and talking to people and even like pouring drinks, controlled remotely by humans that were perhaps in like a Apple Vision Pro, or I'm not sure what. The human is doing the cognitive work to control the robot, but that's how you start to really bootstrap your way into the training data of, okay, when I see this input environment, what do I actually do? How do I pick up the glass and not drop it? How do I pour without spilling, et cetera, et cetera? So all these things they've already come pretty far. The most impressive demo I've seen online recently, it was a robot folding laundry. And, this was the kind of thing that, again, pretty recently you'd have people saying it'll be, never or decades, until a robot can fold laundry. Gary Marcus has said, never in my lifetime is a robot going to be able to walk into my house and make me coffee. And I have to say, I think, if he's willing to open his door to that robot, I think that is almost certain to be achievable in the 2020s, and probably, in the first half of the remainder of the 2020s, if I had to guess. Potentially still at a high price point. Again, these things have to be manufactured. Tesla is definitely putting themselves in position to make many millions of these. Elon has said he thinks there will be more humanoid robots than humans in the not too distant future. So that's a lot. Yeah, I don't see any reason to think that it won't happen. You see NVIDIA too has some really interesting projects these days around simulating data. And this has demonstrated that it can work in other areas of physical science. Like I did one episode on chemistry, basically. A guy named Tim Dagnan had trained a model on the data created by molecular simulation. You have these like super compute intensive simulation processes that say like, okay, here's our configuration of atoms or whatever. Now let's solve the wave equation and figure out what force, is acting on each atom or each even electron, maybe given the configuration that we input. And then we'll like increment a tiny time step, which is like down to the like 10 to the minus 15 seconds or something ridiculously small. And then solve the wave equation again from that new thing. And in that way, they can make pretty high quality simulations of like very small physical systems. And then they train a neural network on that. And then it works, orders of magnitude faster because it doesn't have to do all the intermediate calculations. It can just sort of jump to the answer. And, that's what is also starting to happen in robotics. Lots of simulation, NVIDIA, graphics cards, they're very good at these sort of 3D simulations. And so they're creating tons of this simulation data, which will also be used to train the models. So yeah, I would just expect it can't be all that long before we start to see robots entering the real world. I think the jury's kind of out as to how many of them will be humanoid versus small humanoid. I kind of want them to be like 3 feet tall and not like the same size as me. I would like to think that I could like kick one over and it can't kick me over if it really comes to that. But yeah, obviously if it wants to reach up to my top shelf and actually get the coffee, it's going to have some affordance for that. So, the argument that the humanoid form factor is the one, there's definitely some rationale to it. Especially as the robots come into the real world, these sort of strange, anomalous, aberrant personalities that they seem to have without anyone's intent start to become like less of a curiosity and more of a real issue. So, yeah, like whether anyone should spend time trying to understand what's going on in infinite backrooms or truth terminal, I think is debatable, at least when it comes to the specifics. But the the super short abbreviated story there is a performance artist has put multiple instances of Claude together and just let them talk about whatever they want to talk about. And it actually seems to be the case that Claude has kind of its own vibe that it pretty consistently settles into, which has been described as cosmic trickster spirit archetype. And it gets weirder from there. I don't think, Claude is not the end of history. I don't think this is going to be like the thing that really shapes the future, but it is really important to keep in mind that there's a lot about these things that we still don't understand. And when left to their own devices, whatever that means, or when put out of distribution, talking to each other in a sort of unconstrained environment is kind of putting them out of distribution, then you get weird behavior that is not expected, not designed by anyone, and just kind of like has to be discovered. It's a good reminder that these things are being trained, almost conjured out of resources, but not designed, not engineered in the way that almost everything else in the built world has been engineered. A robot with a emergent personality is like a strange thing to ponder.
I was about to say, yeah, it's an interesting curiosity when you see a model talking to another instance of itself, saying interesting, wild, weird things. But it's another thing if you have a humanoid robot in your house. You want a stable and harmless personality in that robot, and you want to be very very kind of secure in the knowledge that it's not going to change its personality.
And as of now, we do not have a way to create that. I think most people would agree that Anthropic has, in some sense, created the most aesthetically pleasing models. The top performing models, they're typically considered to be like, the most ethical, the best behaved. You can have kind of these long philosophical discussions with them. And yet they have other modes, that are just very bizarre to behold. So, yeah, I mean, I think this kind of connects to a bunch of these other topics where, what is the outlook from here? Well, for one thing, we have the new O1 models create a new scaling law. So now we have kind of two key scaling laws. The first one was just how much pre-training goes in that, predictably leads you to better performance. Now there's a runtime scaling law as well. How much the model thinks at runtime can give you better performance. So that's what O1 is doing. I use that for coding. I'll take like my full code base of a small app and say, give me options for how I might think about implementing this next feature. And it will come up with multiple different plans and reason through them and finally give you, the one that it recommends. They are not sharing the full chain of thought there, presumably because they don't want people to grab that data and then go train their own models on it for probably a mix of business and safety reasons. So we see that happening there. That's another thing that's going to be like hard for people to catch up with, right? This model is already reasoning. It's beating human experts at routine tasks. It's like starting to reason its way through more and more advanced problems. We haven't even seen the full O1 yet, but they have said, think of this as GPT-2. We know how to get to GPT-4.
So all of the big AGI corporations and the big tech companies are investing a lot of money in kind of next level or next generation training runs that are going to be extremely expensive. So they all seem to believe that inference time compute won't be a full substitute for training compute. It's not the case that you can just pour more compute at inference time into GPT-4 and then get kind of infinitely better results as you pour in more compute. Why do you think, do you agree? And why do you think we have that limit? Why can't I ask ChatGPT right now to think for 2 hours and come up with something that's truly brilliant?
Yeah, it's a great question. I suspect it has something to do with just what it can represent internally versus how many different things it does represent internally at runtime. In other words, like if you took a GPT-2 and the old, an infinite number of monkeys on an infinite number of typewriters, can produce the works of Shakespeare. Okay. But in a more, in a somewhat compute bound environment, you can't do literally everything. And you also can't evaluate everything anyway. So you have to have some quality of concepts at your disposal to manipulate. And then the runtime seems to be more about like actually doing more of the manipulation. So you need to have like decent concepts of software engineering to work with to then go down one path and then go down another path and then another path and then evaluate. And it seems like the difference between the GPT-4o and the o1 is not so much the quality of any individual path that it can choose, or that it can go down in the first place, but the fact that it now has been trained to not just do one and spit it out to you, but to do one and another and another. And there's probably some tricks there in terms of how does it decide when to stop and what's good enough. That's some of the know-how that we don't have in the public. But yeah, I guess my general mental model is the pre-training kind of gives you the raw level of capability and the concepts that you can work with. And then at runtime, how many of those you're going to consider and how many different ways you're going to beat them up and how many angles you're going to consider them from is more of a behavioral training question. So, at some point, and I don't like to analogize humans to AIs too much, but if I just do apply this to myself, I do kind of think like, we're more continuous, so it's tough, right? Because as I do this thinking, I'm also kind of inevitably updating. I can't turn that part of myself off, but the model itself at runtime is not updating the weights. So at least as of now, at least as far as we know, nothing like that is happening. So it seems like there is this, you kind of max out, given what concepts you have, how well they can be applied. And so at some point, you just need better concepts in order to make more use of the runtime. And they in that way, they seem to be complements.
Yeah. All right. Back to the big outlook on the future. So you have here predictions from the leaders and CEOs of the various AGI corporations. And when you hear these predictions, they are kind of jarring. We're talking about 2 years, 3 years, within 5 years, within this decade for AGI or transformative AI or some concept like that. What should we make of this? Is this actually happening? Because if it is, then all of our lives are going to change quite dramatically.
Yeah, I think it is. I interpret it as basically earnest guidance as to what to expect. And it is strikingly consistent across all the frontier companies right now. An incredible moment in a not too far in the past Dwarkesh podcast with John Schulman, who's now actually moved from OpenAI to Anthropic, but was in charge of kind of the post-training of the GPTs. Dwarkesh asked him like, when AGI, and he said, well, probably not next year. Like it could happen if one of our training runs goes, better than we expect, but probably more like a 2 to 3 year timeline. And Dwarkesh was like, but that's still really soon. So from that, you kind of get a glimpse into how much they have sort of come to take that as their default assumption. It's not a foregone conclusion, but in his mind, it seemed like, it was less if and more on exactly what timescale, and it didn't seem to be thinking super long timescales. Ariel from Anthropic has said very similar things in their allegedly leaked fundraising deck and otherwise. Shane Legg also, basically said the same thing. Also on a Dwarkesh podcast, he basically said, we see a pretty clear path. Like we think there are some things that we still need to figure out, but we think we know what they are, and we think we can figure them out. And they all kind of seem to be, landing on like a 2027-ish number. It's obviously not entirely, the definition of this is not clear. OpenAI has their weird clause with Microsoft where when AGI is achieved, which is the OpenAI board's prerogative to determine, then they like don't have to license their technology to Microsoft anymore. So I think in reality, a sort of declaration of AGI may be something that happens more for strategic, like negotiating leverage reasons than for reasons of some specific definition having been met. But it seems like, what dominoes are sort of left to fall, and are we seeing them starting to wobble? As far as I can tell, they're all wobbling. Computer use and vision and all these things are kind of happening at the same time. So the big question then probably becomes like, are we in a short timelines, slow takeoff world, or are we in a super intelligence comes relatively quickly after a general intelligence? And that I really don't have a great idea on. It seems to me like we can, we have an existence proof of what really smart humans can do. And I don't see any reason to doubt that AIs can get to a comparable level. When they do, though, they will also have superhuman advantages, and that is almost for sure enough to be transformative. And then there's another question, which I have a much less confident take on. Does that create an intelligence explosion that just like gets out of control, or, maybe not entirely out of control, but just, totally takes off? And do we stay on an exponential curve beyond that point? Or do we kind of level off at like, top of the human, intellect range with also, other superhuman abilities in terms of speed and, energy usage and, ability to recall information and all that stuff? I don't know. I think the leveling off at the top of the human range is enough to create a radically different future. And beyond that, there's a reason they call it the singularity, I guess.
I mean, if you have an AI with the same kind of raw intelligence as the smartest humans, and then that AI can run at a 10x or 100x or 1000x the speed, that's already some very strange creature, and it's debatable whether that would qualify as super intelligence. But you can make that argument, I think, that speed alone is extremely important for your ability to have an effect on the world. So you've laid out for us all of these amazing advances. I think one area in which we haven't seen as much innovation is the area of governance, both kind of self-governance from the corporations and governments responding to risks from AI and potential harms from AI and so on. What is your outlook in terms of governance?
Yeah, time is short. I mean, I think Anthropic put it pretty well in a recent piece where they basically said the window of opportunity may be rapidly closing, and governments probably need to get their act together in the next 18 months, I think was the time frame that they gave, to create some new rules, or else the situation may kind of get away from them in an irreversible way. So I don't, in general, if I don't know what to think, I'll, adopt the point of view of Anthropic leadership. And I think that's a pretty good jumping off point. We've seen like a lot of experiments in sort of exotic self-government from companies, OpenAI, obviously, most notably. That doesn't really seem to have worked. It seems like we basically have Sam Altman in charge there now. And, it's not clear what they're really thinking, or like, I do believe that they're sincere in wanting to create a AGI for benefit of all humanity. I don't know what risk they are willing to take to create that, and if their inner thinking is like, hey, if it's an 80-20, it's worth rolling the dice. I don't know. Right now, it does not seem like they have a plan that they believe will work, right? They had the super intelligence team that's been dissolved and gone away. It hasn't really been replaced by anything other than just more general assurances that like, we'll continue to make AI safe. And of course, we really care. And we're going to work hard on this. But we haven't really seen a clear sense of how exactly. How will you know? What risk are you willing to take to get there? Like, those questions are very much unanswered. And my view is that the governments should do more. And I say that as a basically lifelong libertarian who, mostly would like the government to get out of, a lot of things that it's currently got itself inserted into. Suffice it to say, I'm not somebody who's wanting the government to come in and solve all the problems in society, but this one does seem like there's a role for government, and yet the governments are kind of not sure what to do, right? They don't understand the technology very well. They're behind and, trying to catch up, but it's a challenge. I do this basically full time. And that is another thing that is kind of tipped is like, I can no longer keep up. I I know I'm missing things. 2 years ago, I felt pretty confident that if something really mattered, I would see it. Today, I don't have that confidence anymore. 2 years ago, I felt like if something really mattered, I would even read it. If it really, really mattered, I would get around to reading it. Now I'm like, I can't, I have to satisfy myself with the tweets on a lot of things because there's just not enough time. The number of papers is going exponential, the number of researchers is going exponential, number of startups, number of products, all these different dimensions are roughly following a similar trajectory. So nobody can really keep up with it all. It's very hard to have a holistic view or an integrated worldview of what's happening. And, governments obviously aren't great at that in the first place, right? So I think they have an impulse to do something, but what that something is not entirely clear. The influence of the US versus China rivalry is like definitely pernicious. And one of the things that has kind of made me most concerned over the last year has been to see Sam Altman switch, as far as I can tell, from a previous position of we don't know what China's going to do, and too many people think they do, and try to justify their analysis on an analysis of China, and I don't think that's a good way to go. To now putting out op-eds that say it's Western AI or Chinese AI. There's no third way, and I don't like the sound of that at all. So we're in a tough spot. I think as much as we might like to see governments come in and do something good, I don't have a ton of confidence that they are going to, for all the usual reasons, plus the just extreme difficulty, plus, the sort of arms race, competitive dynamics. All of that is really hard.
Maybe we want to end this by talking about giving kind of like a big picture overview of where we are with AI, both in terms of progress and in terms of the safety of the technology as a whole.
Big question. Let me see how I can do. So progress-wise, all this stuff is kind of a Rorschach test. People are looking at the exact same evidence and coming to very different conclusions, and one wonders how that can really be. I think it is pretty objectively clear at this point that the frontier models are closing in on expert performance on routine tasks. That's always my standard way of framing it, and each word is doing real work there. Of course, frontier models, like you don't get this from, Llama 8B. Routine meaning like there is data for the models to learn from, examples that they can follow, and task meaning like it's relatively finite in scope. It's not yet something that is job sized, right? So I think that's a pretty good account of capabilities with the latest O1 models. You might even say that they're starting to exceed expert performance in some of those routine tasks. And we're seeing flashes of these eureka moments where models occasionally figure something out that people don't necessarily know coming in. I think that is a huge space to watch, right? Can the AIs, come up with scientific hypotheses, for example, that are sufficiently likely to, to bear fruit, that they are worth investing the time and resources to do the offline wet lab or real world experimentation. We do see flashes of that. There was just a report that came out in the last week, I think, that showed that in a material science lab, when the scientists were equipped with a model that could take in requested or required material properties, it could then spit out candidate chemicals, compounds, substances that it predicted would have those properties. And then they would go and, actually synthesize that and measure the properties to see if it was right. And that did meaningfully accelerate the rate at which new successful materials were discovered and patents were filed and so on by like tens of percentage points, not just a couple of points and also not a multiple. It was, kind of in that middle ground of, depending on exactly which measure, 20 to 50% faster science.
You're talking about the new paper from MIT here, Aidan Toner Rogers.
Yes, I think that's the one.
I'll link that in the show notes for people to dig into then.
Somebody said it. I couldn't substantiate this myself. It might have just been somebody guessing online, but somebody said this is bullish for 3M, which is a big American, they make like Post-it notes and all the sort of specialized substances, lots of medical devices, all these sorts of things that have these like extremely well crafted adhesives. They make, a huge, huge, huge number of products. So they're a good, if I don't know if that is actually the company that was being studied, but if it was, it's a pretty big base in terms of the number of new things that they're developing all the time and the number of new patents. So it would be a good place to study that sort of thing. So that's like really, the kind of next frontier is, okay, we have a pretty consistent ability, if we're willing to put in some work, to get the models to do expert level work on stuff that is pretty well trod ground. Can they go beyond that and do things that are genuinely new? Can they come up with insights that we don't currently have? Flashes of that right now. You might even call it sparks of AGI, but I wouldn't say it is the norm. And when I advise people on like practical AI implementation, if they're not, doing deep study and, they're not experts in AI, I typically say, don't even try for that. Just go try to automate something that you want to not have to do anymore in your daily life. You can probably be successful with that, but don't think that it's going to like take over for you when it comes to strategy or big picture, et cetera, et cetera. Because that's like, again, flashes and hard. People put a lot of work into figuring out how to make that stuff happen. It does seem like other modalities are one big way that can happen. Notably, it's not when they used this model at this company, whether it was 3M or whatever, it was not a language model. It was a model that was specifically trained on all of the data relevant to the task of guessing, what chemical would have what properties. So special purpose systems, in any number of ways are typically required to get to that sort of thing. Another big trend there is, of course, automatic verification. If there is some way to do automatic verification, we see this in like math proofs. There are, increasingly every so often you get a report of, oh, this language model was able to solve a math problem or improve on the state of the art solution to a math problem. And how did it do it? Typically, it makes a ton of guesses and gets an objective score in a closed loop where, some theorem proving software or whatever can actually come in and evaluate quickly. Simulation can also do that. We see that a little bit in robotics where it's like in fact, I used to say no eureka moments, and now I have to say precious few eureka moments because of a paper called Eureka that came out of it where they used GPT-4 to write reward functions for robotics training purposes. And I always stop to emphasize there that like, that's not something that, the average person on the street can do. That's like already a, kind of by definition, an expert task. Writing a reward function to indicate to the system, like, are you getting closer to operating this robot hand effectively or not, is a non-trivial thing. But the key that allowed that to work is that they were then able to take the reward function, run it in simulation, and see if it actually worked. So having some way to get quick feedback and then power like a lot of guesses with language models is another way that we're starting to see some of these breakthroughs. And people, again, see this very differently. That some people are like, oh, well, that's not really that impressive. It took 1 million guesses for the AI to come up with a better solution to the math problem. And, that might have cost thousands of dollars or whatever. And I'm always kind of like, well, 0 humans had come up with it, in some of these cases in all of human history. And, what were their salaries, for the people that were potentially trying and not, coming up with that answer. So it's very strange, but I think that's a decent summary of the overall capabilities, and definitely the frontier to watch are those additional eureka moments and other non-language modalities as they get developed into specialist systems and also kind of folded back in and connected with language models. There's definitely a lot of like the language model sort of directing, the specialist model in how to, what space to explore and kind of tying all that together.
Do you think we should generally care about how AIs solve problems? So there are these types of complaints that you mentioned. Oh, it's just trying a bunch of different utility functions, say, and testing in simulation whether they achieve the specified goal. And these, I'm not sure we should take such complaints that seriously. But on the other hand, maybe we can learn something about future progress by considering whether a given model is actually functioning in a general way, or is kind of just using brute force to solve a problem. Is there something interesting going on that frontier?
Yeah, that's a really good question. Again, I think you could see it a lot of different ways. I think it definitely still counts and, should not be dismissed when it comes to just an understanding of how powerful AIs overall are getting and how transformative they're likely to be, because they are still typically cost competitive with humans, even when you're running, millions potentially of generations to get something, that's a little nugget of value. When it's on the frontier, that frontier progress is not not cheap to come by through any known means, right? So it doesn't mean that this isn't valuable because it's more expensive than running ChatGPT or whatever. I do think it really matters when it comes to, the big picture control problem. And there again, you can kind of break this down so many different ways. Narrow systems that are purpose built for a particular domain, you don't really expect an AlphaFold to, in addition to predicting structure or whatever, like also give you paragraph reasoning. It's just not meant to do that. And so, you can kind of take the good with the bad. The good, if you're thinking like control and big picture safety questions, you would maybe like to have that paragraph reasoning, but you can also take some comfort in the fact that like these narrow domain specific systems, like they only do what they do, right? There's not much chance of AlphaFold all of a sudden, taking over computer networks or, breaking out of its environment and, self-replicating in the wild. Those sorts of things seem to be limited to much more general systems. And those like can give you certain account of what they do and how they're solving their problem. The new O1 series of models has this like internal chain of thought, which OpenAI is not sharing with the rest of the world, but which, and they've given multiple reasons for that, one of which, and certainly, a big one would be competitive reasons. They don't want people to take those reasoning traces and then go train their own models on them. Another one is that they feel like, they want to study it deeply and, watch out for weird stuff and so on and so forth. So interesting, mix of reasons that all leads to, we don't get to see those reasoning traces. But I do think for those general purpose things, you really do want them to be faithful in terms of their reasoning, what they're actually doing in the end. You want to be a direct result of the reasoning that they're demonstrating, as opposed to, and sometimes, there has been research that has shown that it's not always super faithful, especially if you kind of set it up in weird ways where you sort of tempt it to answer one way, but then kind of force it to give a reasoning. And then still, like, for example, if you just give multiple choice and all the answers are A, and then you have the reasoning and it like gives an A, it's like, it seems like it's giving an A because all the previous ones were A. It's recognizing that pattern, but it doesn't necessarily say that in its reasoning. And it sort of gives some other explanation. And you're like kind of left to wonder, geez, did it, was it telling the full truth or, and is that even the right way to phrase the question is a little weird, but you would definitely want to see as much as possible. You would want to be confident that the rationale given is the actual rationale that led to the answer, as opposed to some, post hoc generalization, or even worse, if you're worried about deceptive AIs, then you would worry that they might be outright lying to you. And we don't really have a good handle on that. I think there's a lot of different ways that people are approaching the safety problem, of course. Right now, we're in this kind of, I hesitate to use the term arms race, but I think that's not a bad way to think about it, where the models are getting more and more capable. And they're also, just kind of as they go through this post-training process, they're also getting more and more post-training on what to do and what not to do. And that's like gradually working better. The rate at which they do bad things, when prompted, is falling. The rate at which they refuse to do benign things is also falling. And so OpenAI can say, look, our new O1 model is not only our most capable, but it's also our most aligned, as measured by how often it does something we don't want it to do, or, refuses to do something it should do. And that's great. And that seems like alignment and capabilities are the same to a certain degree. But then, of course, one also wonders, does that flip at some point? Are there threshold effects that could be hit where, especially if you have some sort of deception? Of course, I think your listeners will be familiar with the worries about RLHF, where because we are not fully reliable and consistent evaluators of language models, or of anything, the language models have some reason to start to model reality distinctly from modeling the human evaluator. And then that divergence opens up at least some potential for deception. And, to what degree this will pop up naturally is unclear, but it has been engineered. Anthropic has done some interesting studies on things like sleeper agents, where they specifically train a model to, you could call it deceptive or not deceptive. In their one paper, they basically created a model that was harmless in 2023. This was done in 2023, and then harmful in 2024. And they just trained it to behave differently depending on what date it was told it is. And then you could say, okay, well, that's fine, but they engineered that. How worried about it should we really be? The next layer was they then applied just standard safety post-training processes to that model and said, will our normal processes remove this bad behavior if it already exists? And the answer was no, not automatically. So, okay, again, it was engineered, but if this were to pop up organically, would the standard practices eliminate it? We don't, there's good reason to think that it would not at this point in time. And all of this kind of leads us to, I think, just a general state of still pretty radical uncertainty. Like that, things that did not happen over the last 18 months. Like we didn't get the deep fakes in the election nearly as much as we thought we would. And we also did not really get any clarity on really almost any of the big picture questions. All the lab leaders are still saying we're going to have AGI in the next couple of years. There's also like a certain discourse that's like everything is flattening off and scaling is kind of petering out, and you should expect that because we're getting to human level performance, and like how much further could you really go when you're trained on human data? I don't think that's really going to hold. I do think we're going to find other ways to continue to teach these things other than just imitating us.
Say more about that, Nathan. That's interesting. What other ways might we teach AI?
Anything where you can get actual real feedback. Coding is a great example of this. Like, does the code run? Does it achieve the objectives? I think we're going to probably see a lot more of that kind of automated thing. And that'll be better in some ways than others, right? Like we may see poetry kind of flatten off at roughly human level. I'm not sure that we even have a concept of like superhuman poetry or what that would look like, but I would say that could be a real challenge. And it's unclear that like getting superhuman at coding will generalize to superhuman poetry. But that's like a pretty good, contrasting, pair of use cases where code, you run the code, you can quickly execute the code, you can quickly get the error messages, you can quickly run all unit tests. And it seems like there's anything where you can do a sort of self-play type setup is likely to continue to advance. Math is another one. Can you solve this geometry problem or not? We have ways to determine whether a solution is valid. Poetry, creative writing, being a good cognitive behavioral therapist, like those things are probably much harder to objectively evaluate, and the feedback time is definitely a lot longer. Did you come up with a good go-to-market strategy for an e-commerce business? Well, we may not know until a year from now, and that may not ever find its way back into, the feedback process and the training process anyway. So I think we'll probably see some divergence, but there are a lot of things, that of course are fairly objectively evaluatable. And a lot of science is headed that direction. It still right now takes a lot of time and effort to run the actual physical experiments, but there is a ground truth there. And the labs themselves are becoming more automated. And you also have simulation that can sort of sit in between. So it seems quite likely that science will be one of those areas, probably a little slower. The more amenable something is to immediate programmatic evaluation, the faster you should probably expect superhuman stuff to emerge. The slower or the more resource intensive it is to get that ground truth for feedback, it'll be slower, but it should still be possible. And then in some things where it's like inherently a human aesthetic, it may be a different story. There just might not be such a thing as superhuman poetry. So yeah, I think that's pretty good summary of that. The keeping these things on the rails or not on the rails is like it's just very unclear whether we can continue to pilot enough examples of what to do and what not to do that will actually get to something robust. And especially as they, become more powerful and you have these deception worries, it's kind of anybody's guess. That's a pretty natural bridge to maybe the last thing that I wanted to talk about, which is interpretability, which has had an unbelievable last year and a half in terms of progress, because at least for some people, and I definitely count myself among them, it seems like unlikely that we're going to get the level of confidence. It might work, but I don't think we'll be sure that it's working, even if it is working, to just continue to train the systems on do this, don't do this, example by example ad infinitum. It would certainly be a lot more appealing if you could look inside the systems and say, why are they doing what they're doing? And if we could understand that, then you could hopefully have a lot more confidence that it is not just not messing up or not, going rogue right now, but that it genuinely never will, because you really understand how it works. And ideally, you might even be able to detect it if it were going that direction. So, I'm not by any means an expert in interpretability. I don't practice it myself. I just try to kind of keep up with what is going on. And a lot is going on, increasingly tons of different techniques. Anthropic has, everybody sort of knows that they're one of the big leaders in pushing this stuff forward, but they have, if not directly inspired, certainly the other frontier labs are doing stuff like this too, OpenAI and DeepMind as well, of course. And I would say, a lot of, it seems like if you asked people a year and a half ago, or even just a year ago, how much progress we would have made by now, and then you showed them the actual progress, my general sense is that most people would be pleasantly surprised. There was a big sense of like, man, this black box is crazy. We really don't have much traction. We really have no idea what's going on. Maybe we'll never be able to figure it out. And then a lot of things kind of, a certain number of dominoes have fallen. I think Chris Olah does a really nice, he's the interpretability lead at Anthropic. He does a nice job of describing what he thinks the phases of understanding will be. First phase he describes is just understanding essentially what the models are thinking about. Obviously, anthropomorphizing there and, running risk of misleading analogy. But you have the weights, right? In a model, you have the billions of parameters, which are the numbers that are used to process the inputs. And then typically in a transformer, obviously the most common architecture today, you have these layers. And then between the layers, you have these sort of intermediate results. And the intermediate results they call activations, or sometimes called neurons. What is their value and what does that represent is like the first phase. And they have made tremendous progress over just the last year in understanding what concepts are active at any given time. And it's actually turned out, and I think this is philosophical implications too, and probably also reflects that there is a qualitative difference between earlier, smaller, less capable models and today's frontier systems. Everybody's, of course, heard the term stochastic parrot, or at least I'm going to assume people have. Basically, that means like these things aren't really thinking in any meaningful way. They're not representing concepts in the way that we're representing concepts. They're just making sort of statistical correlations between tokens, and that allows them to sort of create a pastiche of something that sort of looks like it's, real language, but it's always just kind of an empty imitation in the stochastic parrot interpretation. My sense is that is probably not too far off for early language models, but these days, certainly with the larger language models, with the interpretability techniques that have been developed, I think we can now say pretty definitively that that's not true, and that there is a higher order conceptual representation that is, gradually comes online through this whole process of training, such that with these big frontier models, we can now look inside and say what concepts are active as the network is doing its processing. So the most famous example of this was Golden Gate Claude, where they put out a version of the model where they isolated like millions and millions of different features. And then they took the Golden Gate Bridge feature, and just artificially turned that up. And that created the effect at runtime where you went to talk to the model. All it wanted to talk about is Golden Gate Claude. And you would have or Golden Gate Bridge. And so they called it Golden Gate Claude. So, it would basically, no matter what you asked it, give you some answer that had some, way of working in the Golden Gate Bridge. The way they do that is pretty complicated. It's called sparse autoencoders. That's definitely been like the new hotness of the last year. And basically that is sort of saying, let's say we have a guess, that, and it is predicated on some, I think, very good hunches from folks like Chris Olah and others who, I think maybe they had more, I mean, they've been at it for years. So I think they certainly have, a lot of different reasons and experiences to develop this intuition, but it was not consensus, view that something like this would work. And yet it seems to have worked really remarkably well. Basically, what they find is that as big as these networks are, and for all the billions of parameters, the number of numbers in those intermediate states, you put in an input, you go through a calculation, you have an intermediate output. Then you do more calculation, you have another intermediate output. Those are not that big. They may be thousands of numbers. They are thousands of numbers, but they're not millions of numbers. So to fit all of the semantic content into that space of just thousands of numbers, some sort of powerful compression has to be happening. And they call the compression superposition, which is basically to say that the same neuron, the same position in that array can mean different things depending on what other neurons it co-fires with. So if you have neuron 1 firing by itself and everything else is quiet, that might mean one thing. But if neuron 1 and 2 are firing, that probably means something different. And if 1 and 3 are firing, and if 1, 2, and 3, and obviously you have a sort of exploding exponential space of the combinatorics of these thousands of numbers. The challenge then is, can you untangle that and figure out what pattern corresponds to what concept? And they basically do this by essentially inserting a super wide layer in the middle of a normal transformer and say, okay, we're going to try to recover normal behavior, but we're going to do it in such a way where you have to project through this super wide layer, like literally millions of neurons. This is like way out of it becomes there's a huge compute cost to doing this. So this is not how they're going to run their thing normally on an ongoing basis. But in order to try to separate everything out, can we take this densely packed, highly compressed, thousands of numbers where the same neuron is involved in bunches of different concepts depending on what it's co-firing with? Can we create a sort of clean representation of that by projecting it onto this millions of neurons wide space and then projecting it back in a way that recovers the normal behavior? And they find that basically, yes, they can do this. And it's kind of a two-step process. First is training the thing so that it mostly works. There is some loss. They refer to this as like the dark matter. They've found millions of features, but there are way more than millions of things in the world. The Anthropic folks have just noted it, or just described this very simply as like, just how many small businesses are there and how many small businesses does Claude know about? I recently went to Brazil and found a Amazon River cruise operator that had one boat, and Claude told me about this business by name.
Without searching?
Yeah, no connection to the internet. I was just like, I'm going to Brazil. I want to stop somewhere else besides I was going to go to Sao Paulo. Where else should I go? It gave me all these ideas. I kind of dug in on a couple of them, and it gave me all the way down to specific by name, one boat, river cruise operator. So when you think about how many of those sorts of things there are, how many different concepts it has to have an accurate representation of to be able to give that level of detailed response, it's like way more than, even 10 million. So they've kind of identified like the most common 10 million, and the rest are sort of lost in that process. And they refer to that right now as the dark matter of this interpretability. So you get down to the level of like, in the interpretability, you might get down to the level of Amazon River cruises, might be a concept, but that specific boat operator, they've not gotten granular enough to separate that sort of thing out. But the two phases are basically create this super wide layer that fires in a sparse way, so that now the hope is that each neuron has an independent meaning. And you can look at, okay, if neuron 1 is firing, that means a certain thing. If 7 is also firing, that means a different thing. So 1 and 7 kind of mean both of those concepts. And this has to be validated. It's not obvious in advance that it will work. But the second step is actually going through and labeling all those neurons and looking at, okay, now we have this thing. it has, we can run the network through this. It does have some loss when we force it to go through this sparse representation, but it like still mostly works. So now can we look at, as we run stuff through the network, what causes each individual neuron to light up and develop some conceptual understanding of that. And they're, of course, then, applying the language models to that. This is known as auto interpretability. And it's like it's saying, okay, Claude, here is a ton of different examples that caused this one neuron to light up. How would you describe those examples? How would you sort of summarize what conceptually is common across all these examples that is causing that thing to light up? And it's like decent at that. I think we should be, and the Anthropic folks are careful to say, like, we don't want to delegate all this understanding to AI. It is important that going back to your question, it is important that we understand it, but we hopefully, when you have millions of concepts, you're going to need help. And so it is interesting to see that the language models are already quite useful in terms of labeling what they call the feature that activates a given neuron in these like super wide sparse autoencoders. A ton of jargon in this space. Anyway, that's all phase one. It's gone really well. I think most people would have said they wouldn't be as far along as they are now, even just a year ago. And then the next step would be understanding the circuits or the algorithms that actually process the information. Right now, we can kind of go in and say, okay, this concept is active. That is useful on its own, right? Because that's how you can steer behavior. They call this activation steering. Anthropic is piloting this, I think, with some users, or it's in like limited beta testing, where essentially you can make your own Golden Gate Claude, but you can make kind of whatever you want Claude within some bounds, perhaps.
Can you get to something very interesting for safety with only an understanding of the concepts involved? So could you get to, for example, an honest model by only having interpreted the concepts? Or would that require interpretation of the underlying algorithms?
Well, it seems like it's a big step in the right direction. I mean, you could both steer behavior, as they demonstrated with Golden Gate Claude, and you can also run detection algorithms, which you can do even without this whole mess. You can just run kind of general classifiers and say, hey, here's the pattern of activations, and this is good or bad, and then train sort of an auxiliary network to classify the activity within the main network as harmful or not harmful. And this is sort of a variation on that, where you could say, okay, if this feature lights up, that's a concern, right? If this feature is bioterrorism or whatever, right, to take the number one concern, if you could isolate a bioterrorism feature, and presumably that does come out in like, if not the first million or 10 million, at 100 million features, like at some point you're going to be able to find that. And then you could say, oh, if that ever lights up, abort, just like stop immediately what you're doing. And that could be quite powerful. It certainly doesn't answer everything. It certainly doesn't, necessarily address open source, but it at least gives you some ability to have, I would say, kind of like order of magnitude. All these things seem to be like order of magnitude questions, right? It's like, it's not perfect by any means, but if you add up, multiple interventions that each kind of give you an order of magnitude improvement, then eventually you do start to get somewhere. And this feels like the kind of thing that can give you, an order of magnitude or like a couple orders of magnitude of confidence that if we see, and of course, in a production system, it wouldn't just be one feature you'd be looking for, but, a whole laundry list. If we see any of these things lighting up, then some different process is going to happen. Maybe we just abort and say, we can't talk about that. Maybe we, flag it for later classification. Obviously, you could have tiers of, sensitivity around these features. And that's basically possible today with layer one or level one of interpretability, which is just understanding what are the concepts that are active at any given time as a network is processing stuff. And then circuits, they're kind of starting to work on now. It seems Anthropic just put out an update on what they call cross-coders, which is looking at how concepts relate to each other. And I might be overinterpreting their work a little bit to say evolve as they go through the different layers of the network. But this seems to be like clearly a first step toward understanding not just what concepts are active, but how are those concepts being processed? How is that evolution happening as you go through the entire process? And this, for context, they just put out, I think a little more than a year ago, but not much more than a year ago, their first toward monosemanticity paper, which polysemanticity is the compressed version where concepts are represented by some subset of, the thousands of activations. Monosemanticity is now we've got millions of neurons and hopefully each one is lighting up for a specific single concept. That also has like a really interesting geometry and sort of almost like fractal nature to it, where they have found that the more you can sort of do like feature splitting, like the more neurons you give the thing, the more granular the features get. And that seems to happen in like a pretty intuitive way where you might see, there's so many different examples of this, but you might see like a Spanish neuron, but then you might start to see like if you gave more room, you might have different flavors of Spanish. You might have like Argentine Spanish or, Spanish or Mexican Spanish. And it just depends on how many concepts you are willing to do the compute to try to separate out. You see like the wider that space gets, the more granular the individual features get. That was just a year ago that they put out the very first thing with like a very small model, kind of a toy problem, a deep study of it that had some real insights. But when they put that out, it was like, okay, this is cool, but this thing has how many parameters? And it was not many. And you're going to ramp that up, to something that has orders of magnitude more parameters, like your actual Claude that you run as a product. I don't think it was obvious that they were going to be able to do that at all, let alone do it as fast as they did. And here we are a year later, and they basically sort of have, with this crosscoder thing, seemingly a first result that is beginning to get at circuits. How are the concepts across different layers related to each other, and how do they evolve through the computation process? So if we're optimistic, a year from now, we might come back and say, hey, they did it again, and now we actually have a really good account of how concepts are being processed, how they're relating to each other, not just what concepts are active, but how those concepts are coming to be active and how they're ultimately leading to outputs. And then the third level would be understanding the thing at like a high level as a whole. And it's not even exactly clear what that means, but it's sort of just saying like, we kind of need to see the forest for the trees. We have similar problems in biology. We can read the DNA sequences. We can look at what's being expressed, what proteins are being transcribed and produced within a cell at any given time. But it's not yet clear, how does that translate to like organism level health and wellness, And so there's a question similarly, like, even if we can sort of describe a lot of circuits, does the leap to like a high level understanding of what the system is going to do at any given point in time, does that like just fall out of that? Or does that take like another, set of novel insights? And I don't think that's entirely clear, but you certainly can't guess that, or certainly can't bet that it will come for free.
Yeah, and I guess ultimately what we want is to ask these kind of broad, open-ended questions like, as a user, should I trust this model? As a developer, should I deploy this model? Something like that. And for those questions to be answered in a fully satisfying way, we would need to understand the model as a whole and understand its behavior. So we would have to have the third level of interpretability. Is that right?
Yeah, I think that would be the dream. We could all sleep well at night, and there could be other solutions that are as yet not invented, that could also work. I guess maybe think about it in two different ways. There's like coming up with a scheme that could work, and then there's satisfying yourself that this scheme actually will work. And those are not the same thing, right? You might find that if we just, come up with the right loss function or, penalize the wrong behavior enough or whatever, that maybe that gets us to some robust safety, but we don't know. We don't know if we're on track for that or not. I've recently did an episode with a couple guys from AE Studio where they are creating biologically inspired approaches to safety, starting with observations along the lines of human empathy seems to be, in a mechanistic way, grounded in reuse of certain cognitive machinery to think about others versus to think about oneself, right? The reason we have like sympathy pains or empathy pains. The reason we, kind of have a good theory of mind is because we're thinking about ourselves with literally the same processes that we're using to think about other people, with obviously some differences, but a lot of overlap. And so they're trying to bring that into AI systems and say, maybe we can make these things inherently pro-social by trying to push the way that they think about or process information about themselves versus other entities, push those as close together as possible. Probably still, again, have to be somewhat different because that's necessary to be functional, but push those as close together as we can. Maybe pro-sociality falls out of that. There has been some evidence that that could be true. They've done some interesting, again, small scale toy problem agent, deceptive agent that becomes non-deceptive when they do this sort of training. So it's very promising. But let's say you do that, and then you're like, okay, cool. We've run X test and Y test and it seems good. And we've got this theory that says it could be good. But if it's going to be like a super intelligence, you'd want to be a little more confident than that. And that's where hopefully this sort of looking inside these things could really make a difference. I've also, one aside, we didn't talk too much about other architectures or state space models in particular, which is a different kind of architecture. But one worry I had when those originally dropped was, and I think they're probably at this point best understood as efficiency mechanisms more than new. They have some advantages and capabilities, but not like super decisive. But what they can do is save you a lot of compute. And hybrids are the way that it's going. People are not moving past attention entirely, but they're creating hybrid structures that have state space and attention mechanisms in some sort of, sequence. I was really concerned that we were going to have to kind of start over on interpretability, because I thought, geez, if you have a fundamentally new architecture that's processing information in different ways, should we expect that all these techniques that we've developed to understand the transformer will work for these other architectures? I kind of thought didn't seem super likely. And to my very pleasant surprise, those problems have not been nearly as severe as thought. I still think you should expect that there's going to be some differences and some surprises in other architectures compared to the one that is most well studied today. But the techniques do seem to work, and they have been applied on some interesting sample problems. Like the Othello GPT project was one where there was like an original transformer version of it where the transformer learns to play the game Othello, and it's just looking at like sequences of moves. And it's kind of like a chessboard. You don't have to know the game too much. I don't really know the game much. But what was remarkable was that just from linear sequences of moves, the transformer learned that this is a 2D game and sort of started to represent 2D structure just based on these like notational sequences of moves. And they were able to, through interpretability techniques, go in and see that and kind of understand like, okay, this is how this thing is working. We can see this representation of the board, even though it was never even told that there was a board. Turns out, same basic techniques applied to a state space model that was also trained to play Othello basically also worked, and came up with a very similar, it sort of is, representing things in a similar way. And they were able to locate and sort of understand that representation in a similar way. So I am very bullish overall on interpretability. And it feels like the one thing that, and again, it's kind of a race, right? Because and it's a weird race too, because some of these things somebody might say, well, maybe we should have stopped at GPT-2, done all the interpretability work, and then continue to scale. I don't think that, unfortunately, is really viable, because I just don't think GPT-2 is like qualitatively the same thing as a GPT-4 plus. It would almost be like, mouse. I mean, the old joke about health results, right? Like you should always append in mice to the headline. And there's probably something similar where, you could do a bunch of things in GPT-2, but does that really generalize to the higher level things? It doesn't seem like it does in probably a lot of important ways. So these things do have to be kind of invented and, or created in order to be studied. And how quickly can the interpretability catch up to new architectures, new capabilities as they come online does seem like a big question. But my update from the last year has been that is just toward much more optimism that all the many different techniques that have been developed actually will work, even if somebody, or at least have a pretty good chance of working, even if somebody comes up with a new architectural innovation that, they weren't designed originally to handle. So that's good. But yeah, we're all headed toward this. The crystal ball gets real foggy, not too far out, and I think this is kind of true for most people. It's like, what trend wins? Is the current question, or can there be some breakthrough that can really resolve things? Right now, the trends are obviously more capabilities, more alignment as measured, and more understanding. But those measurements and those understandings are definitely not complete and don't really make any guarantees about what sort of behavior we're going to see. So, can they get there? Can they get over the hump in time to have confidence when really powerful things are starting to happen? That's not clear. And definitely remains a space to watch that we can maybe check back in on again in a year or so.
Let's hope so. It's going to be interesting to see, perhaps also a bit scary. Nathan, thanks for chatting with me. It's been great.
Thank you, Gus. A lot of fun.